A bit about CloudxLab. The objective at CloudxLab is to make learning fun and for life. So how are we making it fun and for life? One is by the way of live instructor-led training plus the videos. Second is quizzes and exercises. Along with that, we have come up with something called hands-on. Hands-on is hands-on is essentially something that we have come up with whereby you have to go to the lab and there you have to work on it. Third is the projects. Okay, so the fourth is the projects. Along with that, we have case studies, and all of these are based on real life use cases. All right, what is automated hands-on assessment? The idea behind automated hands-on assessment is that we learn by doing. And as per our understanding in the technology, you would not learn anything if you do not do the things with us. Okay, so in the live classes, what we have done is we have come up with something called cloud-based lab. We are the pioneers in this big data lab, and that has changed the way people learn. The way we have the way we have changed it is that instead of having theory class then practical class separately, what we have done is as I teach a concept, I will be doing the hands-on live with you while you will also be doing the same thing at the same time. That makes sure that the the learning is participatory. That makes sure that it is extremely interactive, because whatever you're doing, you are because whatever you're doing, it is going to be when you do the hands-on by yourself, you are going to remember it. You're going to learn it only by doing the hands-on. So we came up with the idea called automated and hands-on assessment. And the idea is that there is an online system if you are going to self-paced one. If there is a problem statement, there is a lab in which you will do the hands-on, and it will automatically check whether you are doing it correctly or wrongly. So it will basically check the output and compare whether it's expected or not. So we have designed the test cases with every problem statement, which checks whether you're doing it good or not. And why we are able to do it? Because the lab is on the cloud and our system has access to the home folder of yours and the whole environment. So we have designed these test case based approach whereby you get the instant feedback while solving the problem at your own pace. All right. So like for example, what we have here is, I'm wondering that some people are not able to hear. Let me just check the audio settings. All right, looks like audio settings are good. All right, good. Now, so here is an example of automated hands-on assessments. Okay, so what you see on the screen is one of the challenges, and this challenge is saying that log in into Web Console, and once you're done, click on I am done. So what it does is when you click on I am done, it's going to check whether you have really logged in or not. Okay, if you're really logged in, then it will give you a go ahead. The second one is here, the second mode that we have come up with using the Jupyter assessment specifically for machine learning and Python. Okay, we have come up with something, a very interesting way of doing the hands-on assessment. The screen is made up of two parts. The left part contains the problem statement, and the right part contains a Jupyter notebook. What is a Jupyter notebook? Jupyter notebook is a basically notebook kind of a structure whereby you write pieces of code and press shift enter and get the output. Okay, so while you on the left hand side it shows the challenge, on the right hand side you can do your work or solve this challenge. Okay, once you are done, you can click on I'm done and it will check whether you have solved the problem given on the left hand side. Okay, you don't have to do any copy paste, you don't have to lose the work, and everything you're doing on the right hand side would be available. So this is something, second innovation which we have done, that to be able to quickly check what you're doing and quickly assess and give you rewards accordingly. So the sole idea is to make the learning gamified something that gives you a joy, something gives you a joy of accomplishing something. All right. So say, for example, here, since I have defined x as 10, x equals to 10, then it has told us that it is a good job. So this is one example of automated hands-on assessment. So that's about CloudxLab. So if you have more questions regarding anything at later point of time, we have a very vibrant discussion forum at discuss.cloudxlab, or you can go to CloudxLab, click on the forums or discussions at the top right, and you will see a lot of questions there. Okay, already answered, or you can ask the question there. So come over to the discussion forum, even if you are not taking up the courses in future, but come over to the discussion forum. Trust me, it is going to help you. All right. Great. About myself, the course instructor, I'm Sandeep Giri, and I graduated from IIT Roorkee long back, and I have worked mostly in my career on large-scale computing. Okay, what I mean by large-scale computing is, say, for example, at DE Shaw, the kind of data we were churning, we had 10,000 nodes cluster. Along with that, the data that we used to get from from New York City to Hyderabad in India, it instead of downloading the data, we used to ship it by flight. Why? Because the data was so big. That was my first introduction to big data. Okay, so this is the story of 2002. You might be wondering that the term big data came later, but the truth is the companies like DE Shaw were already storing and processing massive amount of data. All right, just a trivia, the founder of Amazon was working at DE Shaw before 2002. Afterwards, I founded a company called T-Bits Global, and then I joined InMobi, where I processed around 200 terabyte of data in building one of the state-of-the-art recommender systems at InMobi. Then I worked with Amazon for 1.5 years, and at Amazon, we did the high performance computing in processing the image that is displayed on the detail page, as well as built the mobile app version of the detail page, because detail page is what we owned as a team at Amazon. So most of my career, I have worked on large scale computing. I'm software engineer at heart, and I enjoy explaining technologies even to my friends, to my family members. So this has been my passion to teach people, and that's one of the reasons why we started CloudxLab. So we started CloudxLab as no big data, then we renamed the entire thing to CloudxLab, and the core reason why we founded CloudxLab is to change the way people learn. To change the way people learn technologies. And we have been successful in innovating in many dimensions. All right, so that's about myself and the CloudxLab. The objective of the entire course is to learn to process big data with Hadoop and Spark. So it's a complementary course. Here, instead of saying Hadoop is better than Spark or Spark is better than Hadoop, what we are doing is we are cherry picking the components that are important in big data processing. When you face a challenge of solving or architecting a solution, you should be able to do that after attending this course. All right, and this course will also cover the related technology required for learning to process big data, such as we'll learn Zookeeper and other technologies whenever required. All right, so the objective is that at the end of the course, you should be able to design or architect a solution or solve a big data problem without too much of hesitation. All right, so this is about the course. This is the sole objective of this course. Today's session is the first session out of the huge course. This course is actually pretty huge, and we spend a lot of time in going into the details of every component. And slowly, we are moving more hours to Spark than Hadoop. Like, for example, we have removed some of the components of Hadoop from the course and introduced more parts to the Spark. All right, so that's about the course objective. So we talked about the CloudxLab, uh, about the instructor, and we talked about automated hands-on assessments, and we talked about course objective. All right, so this is going to be uh, the very introductory course. I want to tell you again, this is a general course. Today's session is a very general session. It's going to be a bit of theoretical, and it's going to be um, very non-technical session. While the course is fairly technical, in that it goes into, in case of Spark, we will also learn a programming language called Scala and so on. So the course is very hands-on and very uh, for engineers and architects and senior engineers. But today's session is a general session, and it is meant for people from all backgrounds, the people who are looking for an overview, an introduction of the entire stack. This session is great for the beginners. All right. So in case you are already experienced with Hadoop and Spark kind of technology, then you may find this boring and you may find this repetitive. But if you are new to the whole ecosystem of big data, this course would be a great starting point for you. All right. So great. Again, before jumping into course, let's clear up some of the definitions. All right. Let's clear up some of the definitions. So first of all, a common term when we talk about big data is data variety. All right. Data, when you are going to process data, it could be structured, semi-structured, or unstructured. Structured is the data which has clear specification about the fields and their data types. For example, data in databases is always referred as structured data. Similarly, the other forms of structured data could be in the other similarly formatted sources. While unstructured data, the other extreme, is we neither know the fields nor we know their data types. For example, data in plain text files. Data in plain text files. Data in plain text file is you neither know what are the fields nor you know their data types, right? To convert an unstructured data into structured, you would need ETL. Extract, transform, and load. ETL process is an industry term used for translating or understanding raw data or unstructured data and converting that into structured data. Okay, this whole process is industry vertical in itself. This whole process is an industry vertical in itself. And there are many tools, and there are many big data tools also which help you in ETL. Between structured and unstructured, you have something called semi-structured. What is semi-structured? Semi-structured is the data in which we know the fields, but we do not know their data types. For example, the data in comma separated values, right? CSV format. Okay. The data in CSV format is an example of semi-structured data or semi-structured data, where we know the fields, but we don't know their data types unless there is some third-party information imposed on it and we infer the data types, right? Similarly, the data in other formats such as JSON is also considered as semi-structured because we need to infer the columns, we need to infer the column data types and so on. So on one hand, we have structured data where we have a clear picture of how many columns are there, what are their data types. And on the other hand, we have unstructured data where we have no clue about the fields and data types, and we need to parse the data. We need to understand the data and convert that into structured. And this process of conversion is called ETL. Okay, so basically, this is what we call data variety. Data in industry comes in many formats, and 90% of the time of a data scientist or architect or engineer goes in doing the data cleaning, doing the ETL. Okay, a question from Sachin. What do you mean by fields? Right? What do you mean by fields? Like in database tables, we have columns. In Excel sheet, we have columns, right? Those are what I'm referring as fields. Good question. All right. Now, the other term that we will use very often is distributed systems. What does it mean by distributed systems? One more question I have before I move forward. Question from Renu. ETL only will be used for structured to unstructured? Yes, that's the general term that we use ETL for. Extract, transform, and load. Okay, extract, transform, and load. So that's the ETL process. All right. A question from Subbu, do we have any inbuilt concept in Hadoop for that? Yes. So in Hadoop, there are many components that help you doing ETL. For example, the Spark's RDDs are for ETL, and we have in various input formats designed in Hadoop in order to help you with ETL and so on. Okay. All right. So next question is question from Salim. ETL is applied on all database types. So ETL is not applied on all database types. ETL is generally applied on some data that's not yet in the form of tabular, or some data that is yet to be understood and converted to the meaningful format. Okay. A question from Karan. Please explain the extract, transform, and load concept. Let me just go back to the previous slide. Okay. Extract, transform, and load, right? So if you have a text file containing data, extracting the data from that text file, or extracting or basically reading the data from the text file is called extracting. And then converting the text data into columns and fields is called transforming. And then in the final stage, we do the loading of the data into the target place. So these are the three stages. Okay, a question from Shiva is, how does ETL differ from SQL loader? ETL is a general term. ETL is a general term. It's not specific to Hadoop or Spark or any other thing. It is basically SQL loader could be just one example of ETL. Yes, just to confirm, we are using Q&A window for taking questions. Yes, in the first session, what we have is many users. We have right now 90 plus users, actually 96 users. That's why we are having the webinar version. And in the usual session, we have only the chat one, so that because we can handle a lot of questions in the chat. All right. Next is All right, let me just a question from Karan. Please explain load step more. The third step, we talked about extract, transform, and load. Extract means extracting data from the source. Transform means transforming the data so that it can fit in our destination. Load means loading the data into the destination. All right. So those are the three steps. All right. So a question from Sachin is, who does the job of ETL in Hadoop? So there are many tools like starting from Hadoop Streaming, Hadoop MapReduce, even Hive. All of these components have the capability of doing ETL for you. Okay, and even Spark, the Spark RDD and Spark operations, they all are capable of doing ETL. Similarly, the components like Scoop are good at loading the data, but not they're not good at extracting or transforming. All right. A question from Robin, is Sawmill log parser an example of ETL for big data? That's right. That's right. Okay. So does load involve loading into both physical memory and persistence also? So load here generally refers to, yes, both the aspects, but load here means in the uh, more focuses on moving the data to the target place. All right. A question from Aditya, what is the time duration for performing the ETL operation? So it depends on the data, it depends on your requirement, and it depends on basically the kind of transformation what we are doing. So the general answer is it depends on the number one, the data you are transforming. Number two, the kind of transformation it involves. The third, the size of the data. Fourth, the fourth is the kind of what do you say, the kind of systems you're having. So it all depends on that. Okay. Also, there is always in case of ETL, we would like to keep on bringing the time duration smaller and smaller, and for that you might have we will have to do a lot of optimization. All right, and that's why we go through a course like this, whereby we learn how to do advanced optimizations in translating humongous data in a small time. All right, a question from Shiog, can you explain ETL operation by taking one real-time example, like where do you use it? Okay, let me take an example. All right, it's a good question. So I would love to answer this question before probably this is going to be much use. Good. So now let's move ahead. So here, let me just take a good example of ETL. Let us say that you have a web server, right? In web server, what we do is whenever a user comes to your website or does some operation, they create the web server keeps on putting this information in the text file, and that text file we call as logs, right? And this log file is something that is unstructured, right? Because it has certain format, but that format need to be parsed. It need to be converted into column format, right? Such as a table. So, so on one hand, the web server does not have that much time to keep on formatting data and saving it in certain format, right? So we keep on saving the data from the web server into a plain text file. That's called log file. Now, converting this log file is very, very important. For example, when I was working with InMobi, what we wanted was we wanted to give the recommendations to users just like Amazon does. At Amazon, most of the recommendations are based on the user's past behavior. Okay, and the log file in any organization who is having a customer-facing website, the logs, the server logs, are the gold mine of information. Okay, so using the logs, we generally figure out which what are the most we can actually figure out a lot of business from the log files. Okay, so ETL is taking that log file, converting into a database table, and then give it to maybe product managers, or if not database table, convert it into some other format. Say in Hadoop there is a Hive kind of format on which you can keep on querying without having to translating data by yourself. Okay, so this is one example of ETL. So using the standard tool, we convert it into something that can be quickly queried. So product managers at later point of time could quickly take a look at the logs and look at this extracted information and say that most of my users are from US, or the time period in which the website has least traffic is this window. So those kind of questions could be answered quickly if the data is structured, correct? And therefore, an ETL process of converting logs into that is very important. Good. All right, wonderful set of questions. I will ask a few more questions and then move ahead. All right. So Dilip, this question related performance, we can talk later. All right, not here. This is a very introductory session. You can leave this question in the discussion forum. I would love to answer it there in more details. Okay, this is a very important question. I would love to answer this. Okay, now can we transform different types of data at one time? Okay, so we can do that parallelly. We can do that parallelly, and mm, so yeah, we can write parallel processes which could handle the data and transform it at the same time. All right. A question from Gopi is that what did Karun mean by loading into persistence? Loading into persistence as in convert the data from one form and saving it somewhere else. Persistence means persisting as in saving into the disk. All right, that's what it means. Question from Arsad, does ETL developer Should an ETL developer know some programming if he is already working with tools like Informatica, Talent, and want to study BTL, big data for ETL? All right, good question. So whenever you have to do sophisticated translations, at many point of time, the existing tool may not suffice. Even with the existing tools, you might have to write smaller snippets of the code at one time or another, right? So it is always useful to be hands-on with anyone programming, because if you know anyone programming, you will be able to learn another programming language very easily. All right. So that's my general advice. A question from Noor. What is the difference between big data with Hadoop and big data with Spark? Are they dependent on each other, or they are mutually exclusive? Which one to prefer if they solve the same problem? Is Python used for big data, or do we need to know Java? All right, very good question, Noor. So I'll answer this question now, because this question will keep on coming. This question will keep on coming, and it's better to answer these questions instead of keeping them hanging later. Okay, so first question is, what is the difference between big data with Hadoop and big data with Spark? All right, and basically Hadoop and Spark are two tools, just that Hadoop contains many components for storing data in structured format, unstructured format, and so on, while Spark has the computing engine. So the best solution is to pick and choose the components from both the sides, and that's what this course does. While big data with Hadoop only deals with processing data and storing and handling data using Hadoop, while big data with Spark handles how to do the computation of data with Spark. Big data with Spark assumes that you are okay with the basic concepts of Hadoop. So the second course, Big Data with Spark, depends on the knowledge of Hadoop. So I would generally suggest that you go with the, if you are new to the ecosystem of Hadoop and Spark, go with the entire course. That's, we have designed it in a way that first we'll cover Hadoop, then we'll go into the details of Spark, and then we'll basically cover the entire system. Since there are many people who have already attended Hadoop here and there, therefore we have made it possible to just attend the Spark one. Now, the second question is Python used for big data, or do we need to know Java? Okay, so the way we have designed is, earlier we used to do Java with Hadoop and all that, but we have removed those portions. Okay, whatever programming language is needed in the course, we would teach that. The most of the programming would be required in the Spark side, and there we will teach you the Scala that we are going to use in the course. So nothing to worry on that front. All right. Wonderful set of questions. Question is, all right. So a question from, okay, actually I was supposed to answer Gopi's question. Will we be using Scala or Python in this course? Where is the industry heading? Will Scala or Python will be more in future? So the most of the industry, as I see right now, is going to be using Scala, because whatever you write in Scala can be run in existing servers. You don't need to install anything. And also doing things in Scala is extremely faster. Therefore, most of the industry would head to Scala, because there is no overhead. There is no, that bottleneck of or excuses saying that, hey, we don't have Scala on the server, therefore we can't use it. No. Anywhere there is Java, and Java is everywhere. Anywhere there is Java, we can use Scala. All right. Therefore, I see that things will move to Scala. Now, in case of Spark, if somebody is choosing Spark, they will be using Scala. Scala is kind of midway between Python and Java, and it's quite easy. While on one hand, we have Python, which is extremely easy, but it's slow. We have Scala, which is between, with respect to syntax, it's between Python and Java, but extremely fast. A question from Karun: does all the step in ETL on some dataset need to be performed completed automatically, or intermediate steps or intermediate results from any step can be persisted and used later on to continue with the next stage in the ETL? Okay, so basically ETL is a general term. Okay, there are many ways of implementing, either saying, either having the overall atomic operation and so on. But in case of big data, you don't really have too much of atomic guarantee. Okay. All right, so we will go into more details. I think you all are ready to move on. Okay, I think your questions would be answered as I go ahead. All right, these questions are very useful and very important. Okay, let me just move ahead, and I'm hoping that most of your questions will be answered. If not, I will answer them. Wonderful. Now, let's talk about something called distributed systems. What is a distributed system? Or should I answer? I think I'll just go through the questions once more. There are so many questions. Okay. A question from Rishi: how are images and videos interpreted? Images and videos are interpreted by using their specific libraries of handling images and videos, and those libraries are available on these platforms. Okay, and A question is, how does conversion unstructured to unstructured takes place? Is there a tool for that? You will have to do it by yourself. Spark and Hadoop provide the libraries, but they don't have, you will have to specify that how, whether your data is comma separated, whether your data is in this format or that format. That conversion is what it takes a bit of time to understand. All right. So we are going to learn how to do that as part of the course. All right. A question from Satya. Do we have handled these three types in Hadoop, or we convert into structure? So we do process all the three kinds in case of Hadoop. If we don't always necessarily convert it first into structured and then process, we also, at number of times, we just take unstructured data and process it temporarily and then get the results, and not always keep saving this data in as structured. Okay. A question is, as part of ETL process, do we always convert? Okay. So not always. That's what I've just answered. Okay. Now, a question from Vijay, do we, okay. All right. A question from Salim. You mean you can apply machine learning by using Spark, but not Hadoop? Not true, actually. You can apply machine learning using both Spark and Hadoop. Hadoop also provided something called Hadoop MapReduce, and it has something called Mahat. But most of the things have become more usable in case of Spark. So we have moved to Spark when it comes to the computing. All right. A question from Madhusudan. Considering the data in banking industry is mostly structured, why are banks leaning towards big data solutions? Okay, so banks have all kinds of data. Banks have all kinds of data, transactional data and non-transactional data. Okay, like processing of claims and so on. There are many hundreds of use cases of the data in case of banks, and therefore, and the kind of data they have is generally huge, and therefore they are looking for the big data solutions. Yes, but the transactional data, people still prefer the relational systems as opposed to the big data systems. All right, I'll go into these details very soon. Which one has more market value, Hadoop or Spark? Is it useful in insurance industry? If yes, you can have one more example. Okay, so we'll talk about these examples very soon. And the more market value you would have is somebody who is comfortable with both. Okay, because a lot of times knowledge of Spark depends on Hadoop. All right. A question from Inda, will you teach Java within Hadoop? We'll not teach Java because we won't require Java in this course. We will instead be using instead be, um, so we'll not be using Java in this course. We'll just take one example, and the Java example, we just leave it to you, giving you the entire environment and the exercises. And we will mostly focus with computing with Spark. Okay. So where do we handle data cleaning process? How do we deal with images and video data? All right. Where do we handle data cleaning process? And so, yeah. So most of the computing that you will see in case of big data with Hadoop and Spark is all about data cleaning. All right. Whether whether using Hadoop streaming, whether using Spark, Spark RDDs or Spark data frame, or using some other mechanisms such as Hive and Pig. All of those are oriented towards data cleaning and transformation. Okay, very good set of questions. A question from Nayan is, what version of Hadoop we will learn? We will go with Hadoop 2.7, and we might upgrade the Hadoop on the way. All right. So we always be using and learning something that is important for the industry. All right. So the course is not very rigid, meaning that whatever we have written on the course detail page, we might upgrade it. And as a matter of fact, every new course that we deliver, we only run one session as of now. So every new course that we deliver is actually better than the previous one. Okay, so it'll keep on upgrading without you having to worry about it. That I can assure you. All right. Now, a question from Lokesh. Is Spark knowledge required for Hadoop admin or Hadoop developer? Mostly Hadoop developer. And brief how people already on DBA domain can switch to Hadoop admin domain. All right. A quick point to keep in mind that the DBA, database administrator, is a very versatile profile. Okay. The DBA needs to know SQL, needs to know a lot of things about databases, while Hadoop admin only need to know the system administration. All right. Therefore, for DBA, the right profile to target is the Hadoop architect or Hadoop developer. Okay. All right. So there are many questions. I think as we go ahead, most of these questions will be answered. And all right. A question from Binta. Could you give us a brief introduction to Java during our learning Hadoop? So, okay. So have you seen the recordings? Have you seen so earlier we had a similar request. So what we did was we created a separate course for the students, and I taught Java as a separate course for free to our students. So we recorded that course and made it available for the students. Go through that one. If you like it, it's okay. Otherwise, we can launch a separate course on Java. And let me see if I can make some time for that. All right. All right. So we can do that. All right. You can, how can we do that? All right. Wonderful. Wonderful. So career related questions, and these questions will be answered as we go ahead. So you all are ready to move ahead. Okay. Wonderful, wonderful. So a few more things. This course, whatever components we are going to learn, all of them are related to distributed systems. All the components that we talk about in big data are distributed systems. So moving ahead, so let's understand, what does it mean by a distributed system? What does it mean by a distributed system? It means that group of computers, group of network computers interacting with each other in order to achieve a common goal. Okay, so that's the important part. You have the cyber cafes which have groups of network computer, but they are not achieving the single goal, right? So if you have a process or a project and you want to get it done through many computers, so you need to divide the work amongst the computers, right? How will the division work? And that whole mechanism of dividing the work comes under distributed systems. And what we learn as part of this course is exactly this. Given a problem statement, how would you divide the work among so many computers? All right. So that's the distributed system. So in this course, what we are going to learn is how to utilize many computers to get your work done at a really in a smaller time at a really fast pace. So this is what we call distributed systems, connecting many computers together and being able to solve your problems using many computers is called distributed computing or distributed systems. All right. So just to check if you are with me so far, you can use the chat window, not the Q&A window, chat window to answer the question. How many bytes are there in 1 petabyte? You can answer using the chat window. All right, that's right. So yes, it is approximately 1 followed by 15 zeros, right? So 1 petabyte is actually a humongous data, So, the way you can remember is that 1 petabyte is 1024 terabyte, and 1024 terabyte, 1 terabyte is 1024 gigabyte, and so on. Okay, so so the, so basically, this is what 1 petabyte is. Now, next question to all of you is, how much data do you think Facebook stores in one day? Just a rough guess. There is no penalty on a wrong question, a wrong answer. That's right. So it is approximately 600 terabyte data. Okay. So now we understood what's a petabyte, and we understood what is kind of data we're talking about when Facebook handles. So now the next thing that we would like to understand is, when we say big data all the time, we have been using this term forever, for last few years. So what does it mean? What do we mean by big data? What is your understanding of big data? Okay, three V's. Okay, wonderful, wonderful answer, Gopi. That's right. So we would like to keep the definition very clear. Okay, because we're going to use this term, and around this term, we have created the entire course, right? So, so the definition is data of very huge size. Okay, that cannot be processed with usual tools. How huge? That cannot be processed using usual tools. Now, what does it mean by usual tools? The tools that are not having distributed architecture. So the data of very huge size that cannot be processed with usual tools, and we need new genre of tools, with the new genre of tools which can utilize many computers simultaneously. So that kind of tools. So this is what it means by big data. Big data is humongous data for the computing of which we might require we might require distributed systems. All right. So we'll keep this in mind, that big data processing is all about distributed computing. Big data processing is all about processing data using many computers. That's what is the general idea about big data computing is. The data could be structured, unstructured, semi-structured, doesn't matter what kind of data it is, as long as the data requires multiple systems at the same time, we call it distributed system. All right, so this is what it means by big data. This is what it means by big data. All right, is the definition clear to all? Now, furthermore, um, these are the various characteristics of big data: volume, velocity, and variety. Volume means data at rest, velocity means data in motion, and variety means data in many forms, right? So characteristic of big data, or actually these are the characteristics of any data. Okay, the data could have humongous volume, meaning when we are trying to store so much of data, say in case of storing the logs of a website or storing the emails by Gmail, it requires a humongous storage, and this storage cannot be provided by a single computer. And that's where the volume the volume becomes an issue. So when the data grows bigger in the volume, we can't handle it using one computer, and that's where we need distributed computing, and hence our problem becomes a big data problem. Our problem becomes a big data problem when we have humongous data to store on the disks. Now, the second characteristic of the data is velocity. Velocity is the data in motion, meaning, let's say you have a website like Facebook, which is receiving lot of hits per second. These hits cannot be catered by one server. We need many servers at parallelly handling these many hits and talking to a central place, which is having the information about all users and their home pages and so on. So basically handling a lot of requests or handling a lot of data at the fast pace requires multiple systems, right? So by virtue of a characteristic called velocity of the data, your problem could become a big data problem when a single system cannot cater to such a huge load. Third is variety. Variety is data in many forms, right? So variety means, the variety is a very interesting idea, as in the characteristic of the data. Variety means the problems involving data structures like maps, social graphs, and recommendations. So variety means two things. Variety means the structure of the data and the kind of problem that you are trying to solve. Okay, both of them, complexity and the kind of data, both come under variety. So either because of volume, because of velocity, because of variety, your problem could become a big data problem if you can't handle it or solve it in acceptable time using a single computer. All right, so these are the three characteristics of the data which might push you to adopt a distributed computing or a big data platform. So let's take a case of variety, for example, and also take and in case of velocity, if you want more examples, right now as I'm speaking, the 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 audio and video streams are being sent to 100 people simultaneously. This is velocity. This is velocity. Handling humongous data at a very fast pace is velocity. Now let's take a case of variety in more detail. Let us say we are using Google Maps or using any maps, or we have to design such a system which provides functionalities like Google Maps. Now, if we want to go from place one to place two, right, there could be in many number of paths, and we need to find out which path is shortest. For doing so, we would need to go over all permutations, do the computation that which path is going to take how much time and which one is the shortest. So that would require a lot of computation, and to be able to cater to the user in a reasonable amount of time, we might need multiple systems in the backend. So even if your problem is not velocity, your problem is not volume, still, by virtue of the complexity of the problem, you might end up using distributed computing or big data systems. So these are the three characteristics of the data that makes your problem big data problem. All right, so now let me move ahead and ask you a very simple question. Question is, how much time do you think it takes to read 1 terabyte data from a usual hard disk? Okay, there is no penalty for giving wrong answers. Okay, so okay, All right. This is just to tell you that our assumptions about hard disks are mostly wrong. Okay. All right. So it approximately takes, right? A question that, a good question is, what kind of hard disk are we using? Okay. So you can give a range. You can think of the fastest hard disk and the slowest hard disk and give me an average one. Okay. And here we're talking about hard disk, not solid state hard drive, solid state disk. Okay. So it takes around 6 hours. And yes, one more thing I would like to let you know is that it does not depend on processor, because when you are reading from the disk, the process is slower and almost every processor is faster than that. Therefore, when we are reading from the disk, no matter which processor are you using, the processor is going to be unutilized. Okay, because while reading from the disk, the process takes a longer time. All right. Yes, that's right, Gopi. The bottleneck is disk speed, not CPU. Yes, thank you, Karun. You are right. So if you assume around 50 megabyte per second as a reading rate, it's going to be approximately 5.5 hours. So that's a very right way of doing the calculation. Probably I also did it in the same way. Okay. All right. So what we have is now. Now we know what does it mean by big data. What does it mean by a big data system? We know how much time it takes to read 1 terabyte from a hard disk. Now question to all of you is, if you have to count just the vowels, okay? All right, so there's a question from Maruk. I missed the starting point. Is there any penalty on wrong answers and no answering? So I would say that even if your answer is wrong, don't worry, answer it, okay? And because that's the only way you can interact and you can validate your assumptions, okay? So there is no penalty on wrong answers, all right? But I would strongly recommend that you answer the questions, okay? Wonderful, wonderful. So great. And use the chat window while answering, and while asking, use the Q&A window. All right. Now, next question to all of you is that we understand how much is 1 petabyte. We understand what is one big data. What does it mean by distributed system? So my question is, if we need to just read the 1 petabyte data every day, is it possible using one single system? All right. So now next question is, do you need distributed system? The answer is yeah. Okay. Very good. Very good set of answers. So yes, most of the existing systems cannot handle it. Why? Because as we talked about earlier, it takes 1 terabyte to read the data from hard disk. It takes 6 hours. It takes 6 hours to read 1 terabyte data from hard disk, and to read 1 petabyte, how much time it is going to take? 6,000. Thank you, Karan. It's going to take 6,000 hours. Therefore, we cannot do it every day. Even if we have a humongous hard disk of 1 petabyte size, still we can't achieve this in a single day. Okay, and remember that we are just counting vowels, so processor will not be the bottleneck. It will be the disk which is going to be the bottleneck. Yes, or we can have a system which has the power or distributed system. Yes. which we have power of distribution. So if we have many computers, we could ask all the computers to do the counting of the vowels in parts of the data, and then we sum up all the numbers just to achieve the counting of the vowels. Okay, so basically we would need distributed system, because on a single system, even if we assume that 1 petabyte is very well stored, it's going to take 6,000 hours. All right. Good. Great set of answers. And all right. So when we say the disk speed, either reading or writing, is a bottleneck, what does it mean is that that's the slowest process, and therefore that's what is the one that would decide the overall time taken by the overall process. Okay, and hence disk is the bottleneck. Now, so 1 petabyte is big data, because to even do a very simple calculation such as counting the vowels or reading 1 petabyte data, just like if we are just reading and ignoring, even that would take 6,000 hours. Therefore, we need big data system for such kind of work. Now, here is standard chart. Here's a standard chart. What we have here is that the history of digital and analog storage. So you can notice that on one side we have analog storage. This is kind of shrinking while the digital storage is increasing, right? Analog storage is the paper, the film, and vinyl, right? So while digital storage is the data in hard disk or any other digital formats. All right. So you can see that after 2002, the digital data has exploded, as in more and more data is being captured and stored in the form of digital storage. Okay. Now, why did that happen? Why did that happen that way? The answer is twofold. Devices and connectivity. On one hand, devices became cheaper, fast, and smaller. The smartphone that you have in your hand is actually more powerful than the supercomputers of 2002. And yes, and if you go and check, you'll find that the smartphone that you're using right now is actually more powerful than the supercomputers of 2002. All right. So on one hand, the phones or the devices like phones have become cheaper, faster, and smaller. Those are the three pillars in case of hardware innovation, making it cheaper, faster, and smaller. And they have been able to achieve it at a very fast pace. So the device that you are holding right now is having so many sensors, and it's also cheaper and faster and smaller, and is available everywhere. So on one hand, these devices are capturing a lot of data. People are taking photos, people are writing emails, people are sending messages to others. So devices work like data generation, right? On the other hand, we have connectivity. The connectivity has become omnipresent. Connectivity such as Wi-Fi, 4G, GPS, Bluetooth, and so on, right? So connectivity, when you think about connectivity, it's basically making the communication possible, and hence the data keeps on getting transferred and more data keeps on getting generated. So devices multiplied by connectivity, and this had, since devices were available and since connectivity was there have been a plethora of applications. There have been many applications available to solve the human problems, right? To help in various aspects of human endeavor. Okay. And so basically a combination of devices, connectivity, and applications has led to so much of data. And so the more and more the better and better we get devices, the better get connectivity, and the better would be application. And hence it's a combination of the three things. All right. So all right. So what we understood is that the data started growing exponentially after 2002, and the contribution is because of devices, connectivity, and various applications. Now, when we say computing, let's understand what does it mean by computing. Before, I'm just want to be very clear on uh, uh, understanding of the computing. In a computer, you have generally four components. Okay, although there are many components, I'm just taking a very macro view of the computer. So on one hand, we have CPU speed, or CPU. CPU characterized by how many instructions can it handle per second. Second is the RAM. So CPU generally loads data. We generally load data into CPU, into the RAM, so that CPU can process it really fast. Okay, so RAM is random access memory, or we generally refer RAM as just the memory. The bigger the RAM, the better it is. Okay, and in a typical computer, do you think CPU becomes the bottleneck or a RAM becomes bottleneck quickly out of one and two? Which one becomes a bottleneck first? Right, it's mostly the RAM. It's mostly the RAM. CPU is hardly the problem in our general use case. The same is true when we are building a web server, building a big data systems. It's mostly the RAM that becomes the bottleneck. That's right. Because CPU is, you will be amazed to know that the first iPhone was 200 megahertz. Okay. And that was doing pretty good. So it's generally the RAM that is the bottleneck. Now, the third component that plays a role in the computing is the hard disk, or SSD. We always call it storage. RAM is called as memory, and hard disk, or SSD, is called as storage. Storage is the place where we keep data permanently. The problem with RAM is if the computer is turned off, the RAM, the whatever we have kept in the RAM will be cleared. Okay, that is the general architecture. Now, the fourth component that we keep on ignoring is the network card, or we basically generally call it just the network. Okay, so these are the four components which are really, really important when it comes to processing. And when we talk about big data, at least one of them, at least one of these is going to become the bottleneck. At least one of these, either CPU, RAM, hard disk, or the network. Okay, so this is a general overview of the computing uh, components. All right, a quick question to all of you. Which components impact the speed of computing? CPU, memory size, the speed at which you can read data from the memory, disk speed, on disk size, network speed, or all of the above? That's right, all of the above. That's right, all of the above is the answer. And this is a very important thing to keep in mind. So if your network speed is slow, you can't really utilize multiple storage servers. And hence, it's going to take a lot of time to read data from the network, and hence your overall processing is going to be slow. And when we talk about big data, your data is going to be in the network. Similarly, if your disk size is smaller, you will end up pushing the data to the network, and hence the there will be more latency, or it'll take more time to read data from the network as compared to the disk. Okay, if your RAM is bigger, you can hold more data into the RAM, and hence the speed is going to be faster. All right. Now, all right, before I start with the use cases of big data, let me answer your questions now. A question from Robin is, let me just go up and start from the beginning. All right, I'll just go bottom up. A question from Satya. Sorry to interrupt. Will the recording be shared? Yes. Don't worry. Recording will be shared. And do not worry if you want to just take a screenshot. Keep taking screenshot for your own notes, and feel free to put it on Twitter or anywhere, and just tag us. All right. So, okay, recording will be shared with all of you. Don't worry about that. A question from David. What is the network speed recommended? So quick answer is um, the bigger the better, the faster the better. Uh, but it always comes with a price. So there is the trade-off is up to your kind of requirements. All right. A question from Prakash: can we solve big data processing related problem with in-memory processing for faster processing? Okay. Okay. So can't we solve big data processing big data related processing problems with in-memory processing for faster? So good question, Prakash. So not everything can fit in the memory. Okay. The largest and the costliest computer I've worked on is having 200 GB RAM. Okay. And we realized that since we were handling 200 terabyte of data, we could never ever have RAM as big as our data. Therefore, therefore, the main problem lies in reading that 200 terabyte data from the disk, correct? 200 into 6. Those many hours were required to just read it from the disk. So we had to use 800 nodes parallelly to get 200 terabyte data processed parallelly. So the question is, it all depends on what kind of data are we having. If our data is say few gigabytes, then we may think of in-memory processing. But if we have humongous data, we can't really think of in-memory processing. So in-memory processing is just one way of solving big data problems. Okay. So when it comes to complex problems requiring really, really low latency, in which you have to solve things really fast, as in case of the real-time trading and other things, then in-memory processing using servers like Redis and others would be more meaningful as compared to doing that on a big data platform. So the general answer is it depends on what kind of problem are we trying to solve. All right. The hashtag for CloudxLab is, I think, you just put hash CloudxLab. That will do the job. Okay. Can we make our computers for Hadoop? How they are grouped together? Yes. So you can actually install the Hadoop ecosystem on any of the computers, which is having good enough, you know, the average hardware having say 8 GB of RAM or say 16 GB of RAM, that kind of systems will do good. Okay. And grouping together is something that you can use either of the management systems such as Cloudera Manager or Ambari in order to install it instead of you setting it up entire thing. Okay. So a question from Salim is, what's the difference between big data and data science? Big data is a data which is humongous. And if you are talking about big data development or big data engineering, the difference between big data engineering is data science is that data science is a general term to process or handle everything. Data science involves analytics, machine learning. Data science involves visualization of data and everything. So data science is a field of computer science in which the everything related to data processing is under a single umbrella. Okay, so it's a really humongous field, and big data engineering is one part of that data science, whereby we learn how to use many computers in order to solve a problem. Okay, very good set of questions. These first sessions generally have humongous questions, and that's why these sessions are very useful to many people who are starting. So when you see somebody else's question, be accommodative to that. All right. And that's what we learn as part of this session, that be respectful to each other's questions. And I hope you don't mind me answering all the questions. So because uh, as a principle, we don't let any question slip unless it is off the topic which we put it in the forum. Otherwise, we answer all the questions. Okay. Now, a question from Deepak: can Hadoop cluster be spread over multiple regions and cloud providers? Does latency become a problem in these scenarios? That's right. So it's a very good question. Question is, can we install some of the computers? Let's say Hadoop we are talking about distributed computing, right? Meaning many computers connected together, right? Can some computers be in one region and some in another? Yes. So those kind of scenarios are tackled in Hadoop by defining something called racks. Okay, so Hadoop is rack aware, but again, if you have multiple providers, the latency is going to be too high, and therefore it may not be a great output, but it is very much possible to do. Okay, the other thing is, between the various network provider, you will not be able to create a secure network between them, and therefore you will have to enable the authentication. All right, therefore it's going to be further more, will have a more latency. Rack aware means RACK. Racks are the almirahs in which we keep computers in the data centers. So we can inform Hadoop that these computers are together kept in a single rack, meaning they are connected to each other. And that's how. Okay, good. A question from Madhusudan is, will the course help in certification from the standard vendors like Hortonworks and Cloudera? Yes. What we have done is we have merged the two. Instead of pushing the agenda or trying to sell Hortonworks or Cloudera, what we have focused is, we have focused our entire course towards being able to solve any big data problems instead of worrying about the certifications. So that has led to a course which caters to the certification of both. Okay, so the course is good enough to be able to clear the certifications by Hortonworks and Cloudera. All right. Okay. A question from Minda: we may use GitHub in real job. Could you demonstrate the basic skills about them? Yes. Okay, this is something interesting question. So we can plan a session on Git and GitHub, and uh, this session can be taken by one of my teammates who is better at GitHub than me. So this we can plan it out. All right. So this we can plan it out, and we can probably one of my teammates, say Abhinav or others, could take up this session with you. I'll be there. So let me just think about it, and then we can plan it. No worries. Okay. All right. What is GitHub? GitHub is a website which uses a software called Git for software management. All right. So it's called SCM, and let's Question from Noor is, are these not open technologies? So yes, very good question, Noor. So to handle big data, to handle big data, there was something called Hadoop that was created. There were two vendors, Cloudera and Hortonworks, who started basically contributing to Hadoop, the open source Hadoop. They were the main contributors, and both had their own bells and whistles around the open source one. Okay, so Cloudera and Hortonworks provide the implementation support on open source technology of Hadoop. All right, and the founder of Cloudera was the first one who designed the Hadoop one, while founder of Hortonworks was the first one who designed the Yarn architecture in which was a core component in Hadoop too. Okay. All right. So I think, yeah. A question is, do you teach basics of Cloudera? So we basically cover both. Okay, the main open source component that is required, we cover both as part of the course. All right. So we took the common denominator from both and we're using that. All right, good, good. Question from Sachin was, what is a disk speed? The speed at which we read data from a hard disk or a solid state drive is called disk speed. SaaS is software as a service. Okay. All right, there are quite a few questions. Okay, let me see if I could answer some of these. Okay. All right. The general question I would like to keep it for the later. Okay. All right. So I think these questions would be answered as we go ahead, and trust me, they will get most of these questions are related to Hadoop and things like that. A question from Noor is, amongst all the components which impact speed of computing, we can control, we have a control over CPU, memory, and disk, but we can't change the internet speed. So how huge amount of data travels between the systems? A very good question, Noor. So good question. Let me answer this. This is an important question. The question is, in the diagram that we have talked about earlier, we don't seem to have a control over network speed, right? So when we have capped the data on many computers and we need to process, okay, we might have to transfer data from these computers to one computer in order to be processed. This is something we can avoid using distributed computing, right? So that's where what we do as part of this distributed computing is avoid network transfer. Okay, trust me, this is the biggest challenge that I've seen with many companies or many leaders that we failed to we fail to realize that we do not need to transfer the data over the network. Okay, instead of transferring the data over the network, we transfer the code. Instead of carrying the wood to the X, we take the X to the wood. And that's how we learn to avoid network speed. That's how we learn to avoid network latency. Okay, so it's important to understand network speed because that's what it becomes the biggest bottleneck when we are processing bigger data. If we start transferring the 200 terabyte that I talked about in one of the problem statements, we could never solve the problem. The only way we could solve the problem is let the data be divided on many computers, let our code go to all these computers and do the work then and there on those computers instead of transferring it. And that's an important part, and that's what we will learn as part of the whole course, how to avoid the network overhead. Okay. All right. So good. These questions will be answered. There is a question from Dilip. Why memory computation is faster than the disk computation? Because reading from the memory takes text takes like a nanoseconds, and therefore doing memory computation is faster. Okay, that's one of the reasons. So the way the memory is designed is you could jump to any location in the memory at any point of time, while in case of a disk, we have to rotate the disk and go there, which is a mechanical component, and it takes time to do that. Okay. All right, great, wonderful. Question from Robin is it possible to apply distributed system principles on one VM server? For instance, we have 8 VM hosts, each VM host mapped to a large external hard disk storage capacity. A good question, Robin, and this is something I have seen it multiple times, that here, if you pay a little more attention to it, there is a single storage capacity. There's a single storage, and that is what is going to be the bottleneck, right? So yes, you can learn how to do distributed computing using this kind of environment, but it's most effective when the data is on the same machine where we are doing the computing. Therefore, whether you use the virtual host or you use any other, if the data is stored on the same computer as the virtual machine, it's going to be faster. And because we talked about the storage, right? If let's say there's one single external disk which is being shared by all these machines, it's going to be behave like it's going to take equal amount of time, because most of these disks can read from one location in the disk at one time. All right. So it's not going to be the most effective one, but you can definitely learn and apply the distributed computing principle using this. All right, great. Moving ahead. So let's move ahead. And all right. And also, in case your question does not get answered, please come over to our discussion forum. Because there are so many questions still, and there's around 38 more questions, and we have already answered 85 questions. So I would love to answer things in more details. So come over to discussion forum, and there we can also, go into more discussions. So that's what we spend a lot of time in, answering the questions of people related to big data and machine learning. Okay, let me increase my volume. All right. Also, let me check my audio settings if it's coming from the headphone. Yes. Wonderful. All right. So are you able to hear me clearly now? Now, we talked about what does it mean by big data. We talked about all kinds of data, structured, unstructured, and so on. And we also talked about what are the bottlenecks when it comes to the computing, right? So we talked about what does it mean by processing. So the question is, the big data seems to be a problem, right? Handling such a humongous data, we need so many computers and so on. So what is the point? Why do we need to do this kind of processing? So let's take a look at the big data customers. Let's take a look at the use cases of big data. First example and the foremost one is the recommendation system. Recommendation systems are a great example of the scenarios where humongous data turned into good money for people like Amazon. Okay, so if you give the users, recommendation only on the things that you want to sell, the user's response will not be great. Okay, but if you tell the users that you may also like this, based on the historical behavior of other users, then the users will actually appreciate this part, because this is actually based on the past choices of other users. So okay, so basically when we provide the recommendations to the users find it really useful. Okay, they spend more time on your website, they do more purchases, they um, they basically engage better. All right, so recommendations is a very, very important problem. And with respect to recommendations, the more data results in better recommendation, right? The bigger the data, the better would be recommendation, and hence the big data, it turns into great user engagement and great revenue for companies like e-commerce companies like Amazon and Netflix and others. Okay, so essentially the 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 recommendations is an integral part of almost every company and probably every organization, whoever is having end users data, they can build recommendation systems. And therefore a system like therefore recommender, or we also call it collaborative filter, is actually very well solved and out of the box available to all the users. So for example, Spark MLlib provides you the function to just convert the input data into output. Okay, so let's say if you have the information in this 3-column format: user ID, movie ID, and ratings, as in this user like this particular movie this much, you could use Spark MLlib to generate the recommendations. You don't need to be a data scientist in order to generate the recommendations. What you need to do is you need to prepare this data. You need to prepare this data in this format. All right. So basically, recommendations is a problem that that if you solve recommendation really well, it turns your humongous data into value for your company. It turns the humongous data into a great user engagement. The and good news is that such a complex system recommender, the algorithm is available out of the box. But where is the challenge? Challenge is in preparing the data in this format. Challenge is in doing the ETL, converting the web server logs into this 3-column format. Okay, this is where the challenge is. So all right, so here, this is what we call as a recommendation system, recommender, or we also call them recommenders. We also call them collaborative filtering, and so on. Okay, so whether most of the big data machine learning libraries such as Mahat and Spark MLA provide these algorithms out of the box. You don't need to be a data scientist for using these libraries out of the box. Wonderful. Now, the second use case is in e-commerce, we have A/B testing. Okay, we're going to do A/B testing, for example. In A/B testing, we have, okay, let me explain A/B testing in detail. In A/B testing, we have visitors coming to your website, and let's say you want to improve the website continuously. Okay, and this very important use case. So when I was working with Amazon, and what we did mostly was whenever we built something, we whenever we built something new, we always did the A/B testing. Okay, let's say, for example, we want to figure out which color of the header is better, either the red or the green. So what we do is, for some percentage of the users, we show it red, and for some percentage of the user, we show them green. Okay, now let's say in this case, we have 50% users coming to variation A, which is red, and 50% of the visitors, we are showing it B. And we observe that the variation A is giving us 23% conversion, meaning the people who came here gave us, they bought out of 100%, 23%, as in 23% actually did the purchase. While in case of variation B, the green one, we have only 11% conversion. So question to you all is, which one would you choose? If you are an engineer, will you use variation A or variation B? Right? So even though you may not like red color or it may be against your principles, but since the variation A has shown the results, has given the data very clearly, you would like to definitely go with variation A, right? So this is exactly what A/B testing does. The color of the buy now button at Amazon is a result of uh, A/B testing. The everything on Amazon website is mostly fine-tuned using the aggressive A/B testing. There are many A/B variations are running as of now. Therefore, if I go on a website and you go on a website, there will be various features which will look differently to you and look differently to me. All right. So A/B testing is an integral part of any any e-commerce website or any website. For example, in Google, the search results are aggressively A/B tested. In case of Facebook, the feed that you see is aggressively A/B tested. In WhatsApp, the things that like color of various things are also A/B tested continuously. Okay, so basically in today's world where when you have data, when you have bigger data, it's important to understand that instead of one single product manager doing the user case studies before building the product and so on, what we do is we we launch it to the end user, and then based on the user's feedback, we continuously improve our product. Okay, this is called A/B testing. So A/B testing again requires handling of humongous data, humongous velocity of the users, and keeping track of everything. And therefore, the A/B testing is a great use case of bigger data. More the number of users, better insights into various variations you will get. Okay, A/B. Okay, variation A versus variation B. Okay, sometimes it's also called control and treatment. This is called control and this is called treatment. Let's say control means something that was already there, meaning the null hypothesis in if you are coming from analytics background. So we have control and treatment. So A/B is the same thing. It is very much used in this terminology is very much used in drug discovery and drug testing. Okay, that you give some of the patients a real drug, other patients you just give the pacifier and then observe whether the drug is working or not. All right, so that's what the A/B testing is about. All right, so basically this is the second use case in e-commerce. The more the data, the better is A/B testing. So the big data handling leads to a great value for the end user. All right, wonderful set of questions. Now, moving ahead, the other customers of the big data are governments. They do it for fraud detection, cybersecurity, welfare, and justice. Okay, while in telecom, the big data can be used to understand why customers are leaving us. That is, understanding the customer churn and preventing the customer churn. Then network performance optimization. What does it mean? It means that based on the data of users, we should be able to allocate resources according to the traffic and predicting that what kind of load we are going to get on which days and which location is a big data problem. This can be solved using the historical data available to the telecom. Third is calling data record analysis. Using calling data record, we could do many things and telecoms could do many things. Fourth is analyzing network to predict failures. So if we have clarity on w- the history, if we have the historical data about when did a particular equipment failed or network failed, and what was the status of the data that was coming from that particular equipment, if we have that, we can predict the network failure based on that. So there are many use cases of big data. There are many use cases of handling humongous data in case of governments and telecoms. With respect to healthcare and life sciences, almost everything is a big data problem. Health information exchange is a big data problem because there are so many users and the data need to be secure. It has to be as per the government guidelines, and hence the exchange of the health information between various parties have to be through a big data platform. Second is the gene sequencing. Gene sequencing is again a very hard problem to solve. So I was talking to I was basically working with a friend called Rohit from one of the gene sequencing companies. So they use Hadoop and Spark clusters in order to do the gene sequencing, in order to because gene sequencing is complex and it requires processing humongous data, and this is where the complex data actually there is a complex data as well as the huge volume of data, both result in the in lot of time taken to solve a problem. Therefore, it is solved using big data platforms. Third is healthcare improvements. So we could do the healthcare improvements with respect to based on based on the data provided by hospitals and others. The fourth is drug safety. Drug safety is again there are many use case of big data in case of drug safety. One is having a A/B testing platform for the drug safety and so on. Okay, great. Now, so before I jump on to the big data customers, I like to just go through this. Or actually, most of these questions will be solved. Most of these questions will be solved towards the end, after this next discussion that I'm going to have. Okay, so I'm going to. All right. All right. Now, so the next question, next topic that we would like to understand is we talked about many things. We talked about what is big data. We talked about computing infrastructures. We talked about the great value provided by big data solution, big data processing. So now question is, what are the options that we have? So in general, this is what we have. One is on-premise, creating your own private cloud using Hadoop and Spark, or using AWS with Hadoop and Spark. That's first thing. Second is using a NoSQL systems like Cassandra or MongoDB. All of these could be either your own private cloud or on AWS. The third is using the AWS and Google Compute Engine, their services for storing and processing data. Okay, using the GCE, as in Google Compute Engine, and AWS for processing without your own softwares like Hadoop and Spark or Cassandra and MongoDB. So Hadoop and Spark, Cassandra, MongoDB, they are open source and you can install either locally or on any of the cloud providers. So you can either use these softwares or you could use the services provided by AWS and Google Compute Engine. So Google Compute Engine, or you can use Azure, you can use IBM, and so on. So there are many service providers available. But for this course, we are going to focus mostly on Hadoop and Spark because we believe that whether you are going to create your own private cloud or you're going to launch on AWS, the most complete ecosystem of big data processing is provided by Hadoop and Spark combination. This combination of Hadoop and Spark is something that gives you almost the entire control, as well as it gives you the entire capability of handling all kinds of data. All right, that's why we are going to be here. All right, now, all right, so now let me just go over the Hadoop ecosystem, and then I think your questions will be okay. So I'll answer your questions towards after discussing the Hadoop ecosystem. All right, great. Let's focus on this. Also, yes, your questions are important, and in the Q&A, please use only the questions instead of anything. Okay, so you have two things. One is chat, other is Q&A. Okay, so I'm going to keep an eye on Q&A window. Chat, I may not be able to look at so frequently. So if you have to answer a question, answer using chat. If you have to ask me a question, ask using Q&A. All right, that's generally far more easier for me. And yeah, great. Now, let me just go over a bit of history of Hadoop, and then we will go into the components, and then I'll answer your question, because your questions mostly right now, the questions that I've gone through, those questions are related to how to solve those problems using Hadoop and other ecosystem. So I think it is better to just go over the ecosystem and then come back to your questions. All right. So I hope that will be more helpful to you. Good. So what is Hadoop? Hadoop is basically a software. It started like a software, but it is now an ecosystem of components. All right. So Hadoop was created by dog cutting of Yahoo. And basically what dog cutting was doing was he was he was trying to create his own search engine along with some of the colleagues from Yahoo. In his own personal time, he was building a search engine called Notch. Okay, that was again an open source project. He was joined by Mike Caffarella, and both of them were trying to build a search engine. And then they realized that if they want to crawl humongous data of the internet, when you have to build a search engine, you generally you and what is a search engine? Search engine basically searches in the data that is indexed on your servers, and for indexing the data, you have to crawl the data from all over the world, right? Index is nothing but the way you have on the back of your book, you have this keywords and the place where it was found, right? On the back of your book, you have keywords and the location where the keyword is found. In the same way, search engine prepares the indexes from the various websites. So search engine does the crawling, creates indexes, and then when people want some results, they need to search it. So search engine need to store the data from all kinds of websites from the internet, right? And that data could be, even though index could be smaller, but actual data would also need to be stored. So while they were working on the search engine project, they kind of hit roadblock, realizing that they don't have an existing solution to store such a humongous data. They don't have the existing file system, then existing systems that are available in open source are not capable of handling such a humongous data. But lucky for them, at the same time, Google released or published these three papers. First was Google File System that outlined how Google designed their file system using many smaller hard disks. Okay. The second was Google MapReduce. How did Google do the computing on massively huge data using thousands of computers? The third paper was Google Big Table. Google Big Table was the kind of database on top of Hadoop and MapReduce. So these are the three papers published by Google. These three papers were published by Google uh, at that point of time. And what they did was what Doc Cutting and Mike Caffarella did was they implemented these three papers, and that's what became Hadoop. And they named it after the toy elephant, which Doc Cutting's kid was playing with. So they named after toy elephant, and they made Hadoop as open source. Okay, Apache is the license. Okay, Apache again is Apache started as a software, became a license, an umbrella of components. And similarly with Hadoop, Hadoop started as these three components: Hadoop file system, Hadoop MapReduce, and HBase. Okay, based on these three papers. So Hadoop also started as a single component, but it became an umbrella of various components. Hadoop is under an open source license called Apache. Apache is the most liberal license, which means that you can use Hadoop in educational setting. You can use Hadoop without paying anybody in your commercial settings or in academic settings. So any kind of you can use Hadoop without having to worry about license issues in all kinds of settings. So that's what is Apache license. Apache license is the most liberal license out of all the licenses, right? So Hadoop is popular, powerful, and well supported, and it's a framework to handle big data. It's a framework to handle big data. It's for distributed, scalable, and reliable computing. It is for distributed, scalable, and reliable computing. It is written in Java. Okay, so Hadoop started with three components. Now, as of today, it's a suite of many components, and all of those components are written in Java, and all of those components are distributed, scalable, and reliable. Also keep in mind that even though Hadoop is written in Java, that doesn't mean that we can't use Hadoop without using Java. We can use Hadoop by the user interface. We can use Hadoop using other programming language and so on, right? So here is an ecosystem of components. Okay, one of the components that we have not mentioned here is Zookeeper. Zookeeper is a general component. When you have many computers and you want a coordination, then you need Zookeeper. All right, let's go over the various components under the umbrella of Hadoop. Okay, so here we go. So as we said, Hadoop started as three components, but now it has become so many components. And here, the most important component is Hadoop distributed file system. What is Hadoop distributed file system? It is basically a file storage. Okay, file storage is the most important part of the entire Hadoop. File storage basically utilizes many computers in your network. So you can store a single file onto multiple computers and you don't have to worry about it. So what HDFS does to you is it provides you a single folder structure like you have in Windows. When you click on C:, you have this full folder structure. In the same way, what HDFS does is it provides you a folder structure, just like C colon in your Windows, and or in your Mac, you have your home folder, right? So HDFS provides you this kind of folder structure, but under the hood, these files are located on many components, many computers. These files, which are in the Hadoop folder structure, are stored on many computers. And that whole magic is abstracted from you. You always feel as if you're interacting with normal file system, but under the hood, it's utilizing many computers' hard disks. Okay, so that's the HDFS. HDFS has made it extremely simple to store petabytes of data without you having to worry about the underlying backup and things like that. So everything is done by HDFS under the hood. Okay. The second thing is the resource manager. What is resource manager? Yarn is a resource manager, yet another resource manager negotiator. That's the Yarn. What does Yarn do? Now, we talked about Hadoop file system. Hadoop file system utilizes thousands of computers or hundreds of computers to provide you a humongous storage. What does Yarn do is Yarn utilizes the same set of computers to do the computing, to do the processing. Okay, so if you want to execute something nearer to those pieces of data under the hood, then you can use Yarn. Yarn keeps track of all the computers in the network, and you can tell Yarn that what to execute where. So Yarn is more like an operating system which is distributed and is keeping track of the network resources. So if you want to run something on the cluster, you ask Yarn. While if you want to store data to on the Hadoop, you ask HDFS. Now, since Yarn only provides the bare minimum for distributing the work, but it's always complex to ask Yarn that how to distribute. Therefore, we have a frameworks like MapReduce. MapReduce is the compute engine. So we write the code in the form of two pieces, in the form of like a group by things, and we hand over that code to MapReduce. MapReduce talks to Yarn and get it executed, get your pieces of code executed on the cluster. Similar to MapReduce, we have Spark. Spark also run on top of Yarn, though Spark is not part of Hadoop ecosystem. Spark is separate component, but Spark can run on top of Yarn. Spark can ask Yarn to do various things on the network. So we will write code for MapReduce, or we will write code for Spark. Spark is mostly a competitor of the MapReduce and is actually faster than MapReduce. So people are using Spark instead of MapReduce, not Spark instead of Hadoop. So Spark is only competing with one component of Hadoop ecosystem, which is MapReduce. Okay, so Spark provides you the computation on top of Yarn. So we write our code for Spark, and Spark takes that code and executes on many computers using Yarn. Okay. So the third one is HBase. So we talked about HDFS. What is HDFS? HDFS is good for storing unstructured data in the form of files, right? We can store data in the form of files, but not everything can be stored in the files. If you want to operate on records, correct? If you want to operate on the record, just like database, then you need HBase. You need HBase in order to do the processing, in order to manipulate records. Okay, so HBase provides you a storage in which you can edit the records, just like you have databases that modify the records. In the same way, we have HBase, which lets you modify the records, right? Now, interesting part is that HBase stores its files on HDFS just like your usual databases store the data in something called database files. Okay, so HBase is on the top of HDFS. It stores its data onto HDFS. The since for every kind of thing, we can't really write program for a MapReduce, correct? So whenever we are whenever we want to get things done on our data, we can't really keep on writing the MapReduce. When your data is structured in the form of table, then tools like Hive, which let you write the SQL for processing, are very useful. So if your data is structured and you want to process it using Hadoop, then you could use Hive, which will call MapReduce, which will call Yarn, and which will get actual work done on the cluster. So Hive basically converts your SQL into MapReduce for you under the hood. Okay. Then we have Pig and Piglatin. Piglatin is very similar to Hive. You write, instead of writing in SQL, you write in something called Piglatin, which is very similar to SQL, and it converts that Piglatin into MapReduce and get it executed there. The third component called Mahout is a machine learning library, and these three components, Piglatin, Mahout, and Hive, there are parallel components in Spark also. We call that, in case of Mahout, we use MLlib, and in case of Hive and Piglatin, we use Spark SQL. Okay, so Mahout is library which gives you these wonderful functions like creating recommendations and so on, and you can run. When you run Mahout's programs, these out-of-the-box libraries available to you, when you run those, they actually internally launch many MapReduce programs on top of Yarn. Okay, now in a typical project, we have Uzi. In a typical project, we have many such phases. I'll talk about that. Let's take a case of I'll talk about Uzi later. So here we have two more components. One is called Flume and other is called Scoop. One is called Flume, other is called Scoop. What is Flume and Scoop? So here, when you have your traditional data, when your data is in an unstructured format and you would like to bring it to the Hadoop ecosystem, you will use Flume. Flume makes it possible to pull the data from various kinds of sources to Hadoop ecosystem. All right. While what Scoop does is Scoop brings the data from your usual databases to Hadoop ecosystem. So you have Flume and Scoop for data import export. All right. Yes, all of these components plus some more components like Zookeeper will be covered in the course. Now, we did not talk about Uzi. What Uzi does is Uzi saw. Okay, so let's take a case of let's take a very practical case. Let's see how these components are used in a typical project. Let us say what we want to do is we would like to generate the recommendation. Okay, let me take you through an example of generating movie recommendations or generating the recommendations like the way Amazon does it. Okay, so first of all, from the web servers, we will have to bring the server logs to HDFS. What is server logs? Web server keeps everything in a file, keeps generating this ledger, or you can say logs in a particular file, and those files are called the web server logs. So using Flume, we pump that data to HDFS. What is HDFS? HDFS is a file system which can store mammoth amount of data using many computers. Then what we do is using Pig or Hive or MapReduce or Spark, other things, we do the translation of the data and save back the results. So this is where the ETL is happening. This is where the ETL on Mammoth data is happening. This data could be in petabytes. Okay, so the tools like MapReduce, Pig, or Spark are being used here instead of only pig in order to translate or structure your data. So this is the ETL process. Once that is done, then we feed this data to one of the machine learning library to generate the recommendation. The third thing we do is once the MLlib runs, what it does is it saves the results into HDFS. Okay, and once the results are saved in HDFS, the data is exported to your web server using the scoop. Okay, so you can see that in a typical case, in a usual case of recommendation generation, all of the tools of Hadoop ecosystem could be used. Okay, sometimes more than one tool could be used, sometimes more than 5 tools could be used, and basically they need to be in certain sequence. They need to be in certain sequence, and at this point of time there could be many other phases. For example, before copying the data from Flume, delete the older data, or before regenerating the results from pig, delete the older data and create new folder, and so on. And here at this point there could be many other phases involved. So a typical project might involve maybe 20 such steps in order to get the results. Okay, so here what we are doing is we are the generating the recommendations for the users based on the Apache server logs. Okay, yes, this step number 3. This is where the ETL is happening. Here it's extracting the data and then transforming it and then loading it. So this is where the ETL is happening. Okay, so this could go to Hive or HDFS or NoSQL at this point, and then could be read there. So there could be many variations to this based on the kind of data you're processing, the kind of requirement you're having, and so on. Wonderful, great. So what we have here is, here, this is out of the box, this is out of the box, this is also out of the box, just that here instead of pig, we'll have other components because pig is no longer too much use and so on. So what we have is there are many steps involved in a single project. And to achieve that, we use tools like Oozie. Oozie is like a workflow engine whereby we can storyboard which one to do first and which one to do later. All right, so this is the use case of Oozie. All right, so from MySQL, basically the web server will pull the recommendations and display the recommendations, and MySQL, your database, is being updated by Scoop from the results of your MLlib. Okay, I hope this is clear to everybody. So there are, the point that we are trying to make is that in a usual project, there are many steps. And those many steps are actually utilizing these different combinations of these components. Now, to storyboard which one will be done first, then which one will be done later, and so on, we need a workflow engine. And that's where the Oozie comes into play. So as an end user, either you will interact with Oozie or you will interact with all of these components using their command line interface, or using Java programs, or using other tools like Python. So generally, the normal way of interacting with all of these is either the command line interface or using something called Hue from Hortonworks, or using their individual's interface. All right, so this was a use case of Oozie. Now, we could once we have created the workflow, we could also schedule it every day. Okay. A question from Indao: HDFS is an intermediate to connect the different components in Hadoop. Could they be connected directly without Oozie? Yes. You could write a shell script. You can write your own script, which could execute these things in an order. But in case those things fail, you would not be able to do it in a very user-friendly way. Okay. So that's why Oozie provides all of this in more user-friendly, more robust way. You could definitely do without Oozie, but there would always be chance of failure because you would like to schedule it every day, and in case something fails, we could delegate it back. All right, so this was a quick introduction of Hadoop ecosystem. Now let me just go through. So we talked about Apache Spark very briefly when we were talking about Hadoop MapReduce, which is your computation engine. Apache Spark is a competitor of Hadoop MapReduce. It's extremely fast. It is very general, as in it can do all kinds of processing, and it is approximately 100 times faster if Spark is utilizing a lot of memory, and 10 times faster if it is doing on the disk the way Hadoop MapReduce does it. So it builds on similar paradigms just like MapReduce, and it is very well integrated with Hadoop. Very well integrated with Hadoop. All right. So this is basically the Apache Spark. So before moving to the ecosystem of Spark, I would love to answer a couple of more questions. Those are very much related to the this ecosystem. Let me just see. Uh, this okay. So this one I think we've answered. Okay. We need some ETL tools to work after step 2. Correct. We need at this step we need the ETL tools. All right. And a question from Hector is that the Uzi task we can do in Azure Data Factory. I'll have to take a look at Azure Data Factory once to answer your question, but definitely there are quite a few workflow engines that you can use. All right. A question from Noor. So taking this example, generating of recommendation will not be online. It will be a bad job, right? So here it'll be basically what is a bad job. I'll explain to you what is bad job. Bad job is something which you execute. It does something, then it shuts down. That is the bad job. Those who are not aware about what is a bad job. Now, there are the opposite of bad job. What is an opposite of bad job? Something that continuously runs and it never ends. If there is data input, then it processes that input data and then waits for data to come. Okay, and the input to such kind of computing is things like maybe it's monitoring a folder, maybe it's monitoring a database table, maybe it's monitoring say data coming to a message queue and so on, right? So that's called unbounded data processing, or that's called the stream processing. So the stream processing thumb rule is if there's no data, it'll wait for the data. If it is the data comes, it'll process and put it in the output stream. So are called those are called stream processing, and it is opposite of batch. So this is basically we're creating a batch job which is run every day here in this case. So your understanding is right. All right. Okay, a question from Robin. During initial setup, do we need to create script for each component of Hadoop ecosystem to automate the workflow, or will Uzi as a workflow will provide the automation? Uzi provides the automation for almost all of these components, so you don't need to create separate script. But in case of Hive and Pig, it would ask you to create the script, while for others, say Flume and all, you just have to provide their arguments. Okay, so it provides you, so for a couple of tools, you might have to write the script, for others, you don't. Okay. A question from Subbu, Uzi's bundle of Hadoop configuration, or do we need to do it separately? Uzi kind of get installed along with the whole Hadoop ecosystem, so you don't need to install it separately. Okay. So a question from Karun, is streaming data analysis possible in Hadoop? Hadoop does not provide any streaming data analysis out of the box, but on top of Yarn, you can install things like Storm, or using Spark. You can always create the streaming data processing if you are okay with 1 second kind of latency.
All right. A question from Bintao. How can you integrate Azure within your course? So basically, if you take a look at Azure HD Insights specifically, what is that? It's nothing but the Hot and Works ported onto Microsoft Windows, right? It was possible to port it because the the Hadoop is written in the Java and it can very well run on the Windows. So basically, Azure HD Insights is something that is same as Hortonworks, and hence it is part of the course. All right. A question is, I'll answer your question related to Spark very soon. Okay, I'll also answer related to Spark. I'll answer in a minute. A question from Nayan. Why do we need HBase? We can use HDFS and other tools on top of HDFS. Let me ask you, when we want to say delete a particular line from a file, what does it include? Let's say I ask you to delete a line from a file. What you'll do is you will read the file, create another file without that particular line, correct? So that means deleting a particular line takes a lot of time when we are using the file system, correct? So file system is not designed for for record-based processing. If individual line we are considering as a record, then file system is not great for that. So that's the reason why we have designed something called HBase. If we need to edit, delete, or update a particular record, then file system may not be a great solution. That's why we need HBase. All right, good question. Okay. A question from Prakash, what is Vora in big data scenario? I'll have to do the research on this. I'm not sure what is Vora. I'll have to take a look at it. All right, if you could leave on the discussion forum, somebody else could answer this question, or I'll do a research and then can answer the question. All right. A question from Mikala is that which one is preferred? Which one is preferred currently mostly to use the tools Pig, Hive, and HBase. So HBase is just the storage. It doesn't provide you a way to execute your code or logic. So amongst Pig and Hive, people use Hive mostly, and or people use Hadoop MapReduce streaming instead of Pig. So Pig is something that is kind of put to the side recently after Spark came into play. Using Spark, basically, if you need to do the ETL, you would use Spark instead of using Pig. Okay. Okay, I'll answer Deepak's question later. So Suyogya was able to answer your question related to what is out of the box library. So most of these systems are out of the box. That say we talked about Spark MLlib, we talked about Flume, we talked about Scoop. Most of the systems are out of the box. Okay. And what is the relationship between Uzi, Yarn, and Zookeeper? So a good question. Let me just answer this. So Uzi, we understand. Uzi lets you stitch all the components together, your workflow together, and get it done. Correct. While Yarn executes the program on many computers, and you don't, as an engineer or developer, you don't generally interact with Yarn. You interact with the other layers on top of you interact with other layers on top of Yarn. Say, for example, you will interact with either MapReduce or Spark instead of interacting with Yarn. Now, third is Zookeeper. Zookeeper is an interesting component. Zookeeper is a very general component. It's a very tiny database. It's a very tiny data storage which is available in the network. So many computers can talk to this and write their information there so that they can coordinate between amongst themselves, right? So many computers can do the coordination amongst themselves using Zookeeper. Zookeeper is a tiny data storage. which is extremely fast and extremely concurrent and does not suffer from deadlocks or does not suffer from uh, overload or shutdown and so on. So Zookeeper is a great design and is used. Zookeeper itself is a distributed service for the heavy, to handle the heavy number of requests. Okay. A question from Subbu is, what kind of information will store in Zookeeper? When you need to store tiny bit of information for coordination, you will store it in Zookeeper. You will hardly ever store the actual data in the Zookeeper. So Zookeeper is used not to store data, but used to store tiny bit of information for the coordination amongst your services. Let's say you are running something that is going to run on 50 computers and you want a coordination amongst themselves. In that case, you will use Zookeeper. Okay. Also, Zookeeper could be used for load balancing between the various services. All right. Great. Let me move on. I think there are quite a few questions I would love to answer after the overview of Spark architecture. Okay. Now, the Spark. Now, the second component, which is most important, is the Spark. What Spark does is Spark provides us way to process data, while Hadoop provides us the place to keep the data in the form of files or in the form of HBase, which is in the form of records in HBase. Spark provides a way to query. Spark provides a way to process the data. Okay, so Spark is a general engine which can run on top of Hadoop. If you don't have Hadoop in your ecosystem, in your organization, then also you can, let's say you are using EC2 or Mesos, or if you have neither of the systems in place, you can install Spark's cluster in the form of something called Spark standalone. So Spark can run on any of the existing systems. Spark core is the one which contains the main parts to do the distributed computing. Okay, when you want to distribute your computing, you use Spark core. So Spark core runs on top of, or can run on top of any of these resource managers, whether Amazon, whether Hadoopian, whether standalone, whether Mesos, and so on, right? So Spark can read from various data storages. It can read the data from HDFS, it can read the data from HBase, it can read the data from Hive, it can read the data from Tachyon, it can read the data from Cassandra and write the data back to all these sources. Now, so Spark can read and write to various data sources. Now, even though you can talk to Spark core in terms of usual programming, in terms of maps and reduces and so on, but that's not really optimum, right? So in many cases, you would like to process data in the form of tables. If your data is structured, in that case, you will use data frames. It provides something called streaming. Using this library, you can create the continuous data processing. It provides MLlib. It's the most comprehensive machine learning library on big data. And it provides something called GraphX. GraphX is your graph processing engine. If you have a complex graph of things like Facebook graph or Twitter graph, like who is following who and so on. So those kind of graph processing can be done using this. So if if you want to do the basic computing, you could use the Spark core, but mostly if your data is in the form of data frames, if your data is in the form of structured, we could use SQL with Spark data frames. So data frames make it possible to write or express your need in the form of SQL. While streaming, with the streaming library which is designed on top of it, you could process data that is continuously coming. If your requirement is really complex, such as generating recommendations and do all kinds of predictive analytics on top of your data, you could use MLlib. And if you want to do further more complex things like processing a complex graph of things, complex graph of objects, then you can use GraphX. These are the libraries on top of the core of Spark. They internally convert all the logic into this. And then this one gets its execution done on many computers, either using Hadoop or using Amazon, using standalone and Mesos. Also keep in mind that if your organization was using Yarn already, you don't need to install Spark separately. Spark will be installed automatically when you execute a Spark job. It'll basically be launched on all the nodes in the Hadoop cluster. That's why we are able to provide, as part of CloudxLab, we are able to provide many versions of Spark. Because whenever we launch a job, it automatically copies its libraries to all the machines in Hadoop and get it done. All right. So to interact with all of these components, either we could use SQL, you could use R, you could use Java, you could use Python, you could use Scala. So the language war is no longer there. Is no longer there. Now, why did we choose Scala for this project? One, because Spark is written in Scala. Therefore, Scala gets the latest functions, whatever are implemented here. That's one of the reasons with respect to Scala. Second, in the industry, people are asking for Scala. So we are just keeping our course updated as per the industry demands. All right, so this is Spark's architecture. Now, let me go to your questions. So if you have not signed up for the course, you can sign. There are a couple of more seats available. Now, before I move ahead, I'd like to answer your questions. First question from Vinta is, in which scenario, which resource cluster manager should we pick up to use respectively? Good question. I'll go back here. So question is, out of these resource managers, which one should we use, right? So answer is whichever your organization have. Okay, and let's say you don't want to store humongous data and you don't have any of these systems in place already, then which one should I use? In those cases, you could use the standalone Spark manager, standalone resource manager of Spark. This one comes with free with Spark. Okay, so if your organization is neither having Yarn or Amazon EC2 or Mesos, then and you don't need to store humongous data, then you go with standalone. If you need to store humongous data, then you might want to go with Hadoop, and you can install Hadoop. Along with that, you will get Spark by default. If you're installing either using Cloudera or Hot&Works, you will get this by default. All right, so that was the idea behind picking up the resource managers. Now, a question from Binta is, there are so many library packages in Scala, Python, Hadoop, Spark, Hive. Could you give us a general introduction to them and how to grasp them and teach us most popular ones? Is this a strategy for you to us, something new to us? For you to, okay. All right, so here, basically, I'll tell you very quickly, okay? So in very layman's words, I'll explain to you. So you use the Hadoop and the ecosystem for the storage, okay? As per the course, right? So one is that you already have data, and if you don't have data already chosen the framework and you are looking for, and so you might want to install Hadoop with the Spark. Okay, now the next question is when to use which library. So whenever you want to do processing, you should generally use Spark. Whenever you want to do the standard storage kind of things, then you use Hadoop. All right, now so essentially what I'm saying is Hive and MapReduce are no longer used. Okay, they are basically used through here. Now, Whenever you want to do the unstructured data processing, you use Spark Core. If you want to do the structured data processing, you use data frames. Or if you want to convert the raw data into data frames, then also you use this part. The second is, if you want to continuously process data, you use this. If you want to use the machine learning thing, then you use this, and so on. So I hope that is clear. And the language is up to your comfort level. Okay, language is up to your comfort level. So whatever can be done with Python can also be done with Scala or Java or even R. So just that with SQL, you can't process the unstructured data. Okay, this one you can only process the data frames, and while all these four, with all these four, you can process all kinds of data. And so that is that's the quick answer to your question. A question is, amongst various different data sources, which one is preferred one, and on what basis should we go for a particular data source? It is basically a function of where is your data. Okay, and if you want looking for a low cost humongous storage, you can use HDFS or something. All right, good. Let me just go up and try answering your question. Wow, we have still the 57 questions, and I would love to answer those. Okay, now this one we have answered already. Okay, a question from Arshad: can we do data profiling analysis before performing ETL in Hadoop? Okay, so can we do data profiling or analysis before performing ETL in Hadoop? Again, if you are trying to do the data profiling or analysis before performing ETL, what you have to do is you will have to sample data and you will have to bring it locally and do the analysis, right? Since the data in case of Hadoop and others, the data is generally humongous. So if you have like 200 terabyte data, you would like to sample it, get a small set of data and do the profiling and analysis before handing it over to Hadoop. So yes, this can be very well done. Okay, what is the different versions of old Hadoop version and new? So Hadoop 1 was there and there was Hadoop 2. Hadoop 1 was only supporting MapReduce, but later on they started in Hadoop 2, they started supporting all other processing engines, including Spark and others. That was the quick difference between the two. All right, so that was one big difference. Second was with respect to HDFS. HDFS became more robust in Hadoop 2. All right, a question is, okay. A question is how this big data work is different from business intelligence work. So big data work, so business intelligence work is driven by what we want as the end result, right? While big data work could involve business intelligence or it could involve ETL and so on, depending upon the size of your data. If your data is really humongous and you need multiple computers, then same BI work would become the big data work. All right. So a question is, how can business intelligence guy working on reporting can switch to big data? So you will be able to switch to this because here, let's take a case of, let's take a case of this one, right? So at this point of time, when you have converted your raw data into data frames and started this SQL engine on top of Spark, so you will be able to connect to SQL from your BI tool. You will be able to connect to this from a BI tool and represent this humongous data in the reports. And every time your BI tool is going to query this is going to run on top of the big data framework. So this is where you could do. Similarly, let me go back one more step. In case of big data also, in case of Hadoop also, if you are, let's say here, you can query Hive from your standard BI tools. Okay, so essentially you will be able to write your query as if you have been using the standard JDBC systems and would be able to write the BI, all your say BERT or say Tableau and other things will be able to talk to Hive or Spark SQL in order to represent the outcome. So this internally is going to uh, process the data using thousands of computers. All right. So the BI, as you can see that the big data world and the BI world is very well connected. The only difference is in the BI world, we have been using only the MySQL, but here we are going to process humongous data. And for BI to work, we might have to translate unstructured data to structured, clean it up, and keep it ready for the reports to be published. So both the skills, reporting or BI, is a complementary skill in the big data world. All right. Okay. A question from Rishi. What about mainframe? I don't have much idea about mainframe. Okay. Whether that can handle big data or not. And question from Satyajit is, what's the difference between supercomputer and distributed systems? Both handle big data? Not really. Supercomputer is nothing but really a computer with is having huge memory, many cores, and so on. Supercomputer generally today is capable of running many programs parallelly on the same computer, while distributed system is capable of utilizing such computers, which are supercomputers or normal computers. The distributed systems are capable of utilizing many computers simultaneously. Okay, so that's one big difference. Supercomputer is a single computer, and while distributed system could have distributed system is made up of many computers. All right. A question from Noor. My PC has 2 CPUs and 8 cores. Will it be counted as distributed computing or not? No. It's basically parallel computing. Parallel computing is a generic term to execute things in parallel, okay, whether on multiple computers or multiple CPU. Every computer in today's world is having multiple CPUs in general, like our laptop has 4 cores or dual cores and so on. There's nothing but 2 CPUs on the same computer, right? And parallel computing is a general term to execute things in parallel, whether on the same computer or on different computer. So distributed computing is the parallel computing, which is launching the program parallelly on many computers. So distributed computing is essentially utilizing many computers. So answer is no. Okay, how big data is different from BI? While big data is a generic term, so big data computing, let me say big data analytics is different from BI. In BI, we generally process the smaller data and smaller data, or in BI, we are more involved with visualization. And big data processing is just opposite of that. Big data processing, any of these components that you see here on this screen do not do data visualization. The data visualization is still done using BI components. All right, so both are complementary to each other instead of comparing with each other. What is the role of data lake in big data space? So generally, since everything is stored in, say, HDFS, so HDFS is considered as a data lake in this ecosystem. So data lake as a concept is the place where we put the data from all places, all systems, whether Hive, HBase, or other systems, they all store data in this HDFS. So data lake is a general concept whose instance is HDFS. Okay. Now that was a quick question from Satya. Which cloud deployment is best for Spark streaming for real-time analytics? Which cloud deployment is the best for Spark streaming? So any cloud deployment could be good for Spark streaming. Okay, just keep in mind that Spark streaming is great if your expectation is with 1 second. If you want the processing to be lesser than 1 second, you should generally use Storm and other systems. Okay, now a question from Nayan is, in general, do most people use AWS, Azure, or other cloud computing platform, or have their own set of distributed computing? It's a very hard question to answer. So as per my experience, most of the people I have met, they generally use AWS, Azure, Google Compute Engine, and others. While while the so while there were a couple of people who are specifically from telecom domain, they had their own private clouds. Okay, so the answer is AWS, Azure, or Google Compute Engine, or other like IBM. Those were the general choices of cloud computing platform. Okay, a question from Syoga is, as per my knowledge, Hadoop is software that can manage the cluster computers. How is big data coming to picture with big data? So yes, so Hadoop is helping us processing the, I hope this question got answered when we discussed the other things. Okay. Question is, how can I visualize the Hadoop cluster? Let me just answer this question. So let me just show you how it looks like with. Okay, let me just show you how, say, so we generally, when we are installing the Hadoop cluster, we have used something called Ambari from Hortonworks. So using Ambari, we installed the whole cluster, and you can use the similar system. So here it is showing us HDFS. So what is CloudxLab? CloudxLab, basically we are providing one of the labs to all our students and everybody in this industry who is trying to use the big data platform for learning or for building the proof of concept projects and so on. So here, what we have is a cluster already running for our users so that none of our users have to install anything. So here we have HDFS, and you can see that it has 7 data nodes running. Okay, so this HDFS, Hadoop Distributed File System, is the same one that we have talked earlier. This HDFS is essentially running on 7 machines concurrently. Okay, it's running on 7 machines concurrently. And then we have MapReduce installed. MapReduce is not a service, it's just the clients. Okay, and we have Yarn. What is Yarn? Yarn is something that executes things on many computers. So it installs all these services on many computers. Then we have Hive. Hive is again, it has Hive server and Hive clients. So this is how you can visualize the entire ecosystem. Okay, so this is how the tool like Ambari helps us visualizing and managing or provisioning a Hadoop cluster. The same thing could be done using tools like Cloudera Manager. Well, Ambari is from Hortonworks. The Cloudera Manager is from Cloudera. Okay, so what you have is this. This is how you can visualize the cluster. Okay, if you are looking to operate, if you go into CloudxLab here, click on My Lab. Here, what you have is, so say if we have here, this was Ambari. So once you log in into CloudxLab, you will see there is a login, password, and everything provided to you to the cluster. And you can just, you can basically sign up for the lab and get all the services right away. And here what we have is, you can, to take a look at the whole cluster, you can use Ambari. To interact with individual components, you could use Hue. Using Hue, you can say create your own workflows. You can go into say here using say Uzi workflows and interact with. All right, let's say I'll just open existing workflow. Okay, so you could create workflows by drag and dropping various components of Hadoop ecosystem. You could create drag and drop a Hive script, and this is the workflow that you can create. So either using Oozy, you could interact with all the components, or you can directly talk to Hive using Query Editor, and you can interact with all these components from the Hue. So on one hand, you have Ambari by Hortonworks. On the other hand, you have Hue by Cloudera, which helps you interact with various components. Okay, I hope that answers your question. All right, so a question is, do we use the same user ID or password to log in into Ambari Hue? It is a good question. For everybody, it automatically creates a separate user. For me, it is this. For you, it could create another user, and everybody gets their own workspace so that you don't you don't get your data intermingled. Therefore, we have the separate workspace, and the workspace is separated based on Unix and the Hadoop file permissioning. So people can't step on each other's feet while using the ecosystem. Okay. Earlier, we were using a single user when around 2.5 years back when we initially started. And now we have the entire system whereby you have the credentials and everything for per user. Okay. A question from Raja. Hey, I think I'm not sure you were able to see my question. I have been posting it multiple times. Okay. And here's what I asked for. Let me answer your question. Is Spark used to push data into HDFS, or is it only used as batch infrastructure to run MapReduce jobs after it is stored in HDFS? So, okay, let me answer. So Spark is used to push the data into HDFS. Yes, Spark can save the results after processing into HDFS. Okay, so Spark is not using the MapReduce as such. Spark is a separate component and is a competitor to standard MapReduce, and it's faster than the MapReduce. It's faster than the MapReduce, and it is quite robust in terms of computing. Can you describe the use case where Spark is used as part of pushing data into HDFS? So if you take a look at this, here also, this portion can also be handled using this portion can also be handled using the Spark. Okay, so this as well as maybe this can also be handled using the Spark. Okay. All right. A question from Mikala is that how it could be carrier in Scala, Akka, Play framework. So I would love to answer this question. I would love to understand this question a bit more. So how it could be a carrier in the Scala, Akka, and Play framework. So yeah, so basically, let's say on the web server, you are running the Play frameworks. So you can do the processing here, and then the rest of the processing will be done, rest of the presentation of the data can be done with the Play framework. Okay, while the computing on the Spark can be done using Scala or maybe Akka. All right. So I'm going back to the top and see if I'm able to answer your question. Question is, how can we master data science from scratch within how much time? It all depends on what do we call data science, because data science is a humongous subject. And to my understanding, it would at least take 6 months of time to actually learn machine learning along with big data. So data science, as per my understanding, is normal SQL along with analytics, along with machine learning and the big data. Right? It could take minimum of 6 months to work with that. And it also is a function of your background, as in whether you have already studied Hadoop or already studied machine learning and so on. Okay. So Any standard size or pattern for defining cluster, or it solely depend on our requirement. So minimum of 3 to 4 computers are needed in case of Hadoop ecosystem. Therefore, rest is up to your requirement. Okay. A question is, how can I visualize Hadoop cluster? We did this. A question from Nayan is, in general, do most people use Azure? Okay, this we have answered already. Okay. So Hortonworks provides services to, yeah, that's right, Hector. Okay, what's the market value of data scientist? The data scientist is probably the most highly paid, highly paid and in demand as of today. Okay. So yes, we will be either using Hortonworks or Cloudera in real life. Okay. So could you introduce some of the common tools like IDE or Eclipse and so on? Yes. So I think what you should do is you should come to CloudxLab here. Go to once you have you go down here, and there is here you see writing Spark application. Okay, take a look at this one. All right, take a look at this one. This one walks you through how to use IDE with the Spark. Second thing, you should take a look at this particular one, MapReduce programming. This one talks about how to use the IDE with Eclipse. Okay, and rest of the work you can get it done using Hue. All right. So a question from Lokesh, is there a dedicated course for Hadoop Architect? So I think the first part where we talk about the whole architecture of the ecosystem and go into detail, that should be sufficient for most of the Hadoop architects. A question from Madhusudan, what components of big data actually splits data onto distributed systems and what is used to join them back for post-processing? Okay, this is the pretty hard question to answer. So basically, the first set of division of work happens when we store data in HDFS. At that same point, when we are, say, storing a file of few hundred GBs onto HDFS, it is going to break it down into parts and keep it on many machines. So that's the first point of splitting the data. Okay, and then we do all kinds of processing on top of it, combine and do the merging using the Spark or MapReduce or Hive, and then save the results back to HDFS or some other place. Okay, and once we are done with that, we can expose that data via Hive server, so that your traditional systems can query that data using your existing visualization tools. Okay. A question from Rishi, what are the different tools we should know while working on big data project apart from Hadoop and Spark? Okay, so the other tool you could be using maybe a visualization tool called like Tableau. You should take a look in case you are looking for Tableau. Our team has done a good job here. So here what we have is, let me go up. So you take a look at this Hive project here. So Hive project basically walks you through a standard project in case of say sentiment analysis, and in last it represents the data using the Tableau. Okay, so other than the usual tools that we have talked about, this one talks about the various components as part of Hadoop and Spark. All right. So a question from Prabhat is, what are the real-time industry applications of Hadoop? Wherever there's a batch processing or stream processing, we use Hadoop and Spark combination. There are many such there are many applications wherever the data is bigger. You don't have much choice other than using big data framework such as Hadoop and Spark. Okay. I hope I've been able to answer your question. Question from Sandeep is the system configuration required for practical. So the good news is that with respect to CloudxLab, if you can even the very low end computer on which you can use the Gmail, you can use CloudxLab because you don't need to install anything at all. What we have done is we have made everything available in the browser. If you take a look, we have Ambari in the browser, Hue in the browser, then console, instead of you installing any terminal or anything, it will basically open the console in the browser. Okay, like here, you can just copy paste it, or even better, you have Jupyter. Jupyter provides you the entire ecosystem to talk to your home directory in our cluster. Okay, you can actually create, you can start working on Python, Scala. This is for Spark, and this is R. And you can also start with terminal. Okay, so those are the so you don't need to worry about installing anything on your computer, and therefore any low-end computer, any computer on which you are comfortable in, if you are attending this meetup, right, using Zoom, therefore your current computer is also sufficient to use the big data lab right away. Okay, a question is, what if we want to retrieve huge data after computing from distributed systems? If the data was spread across multiple systems, suppose all the transactions happened over a 6 months period across the globe for the bank. In this case, how will data be merged together? This transformation part of ETL comes into picture. So if you have humongous data already spread across the the data center, so that you don't have to worry, that's actually done as part of HDFS. And when you want to process it, what you will do is, instead of processing and bringing it on one computer first, what you do is you first do the processing in such a way that the individual computers solve make the data smaller, and then you can bring it together. Okay, and you can actually, that's what the whole MapReduce computing, and that's what the Spark computing involves. Learning that part, how to merge and how to do that. Okay, so also please note that even if your data is distributed on many computers, you could actually use SQL to do that, to do the transformation, to do all kinds of processing without you having to write the code. Okay, and hence the entire ETL and entire things can be done using your data on many computers using SDFS. I hope that clears it. Or let's say you have data not inside Hadoop initially, data was already on many machines in your data center. You could use tools like Scoop and Flume to pull that data to HDFS and then do this processing using Spark on this data. Okay. Question is, does it require CSV format data? And what would be the format? Can it handle JSON data? All right. So actually, those who right. So we are kind of done with the session. You can enroll for the course if you have not already enrolled. This course is going to be very aggressive in terms of the number of classes, and this course basically will take you through the entire ecosystem and would basically do the hands-on on probably every component in the ecosystem. So there are a couple of seats available, and generally our seats kind of fill up in a couple of days. So so if you are interested, you can go ahead right away and enroll. You can just go to cloudxlab.com and enroll. All right, now let me get back to answering the questions. Question is, I'm just going to answer the questions from this point onwards. Okay, a question is, does it require CSV format data? What would be the format? Can it handle JSON data or simple columns like we can extract in Excel sheet? No, you can actually handle all kinds of data. We'll teach you as part of this course, so you can handle all kinds of data. Okay. All right, so I hope big data solutions made sense to you. The various kinds of ecosystems that could help you handle humongous data is called big data solution. Question from Dilip, why accumulators are fast compared to other variables in Spark? Because that's how the Spark has designed those. Okay, because accumulators are one way, they keep on, uh, so, so accumulators are part of Spark core. Okay, when we are programming in Spark and we want to continuously receive the response from many computers simultaneously, we create something called accumulators. So I think this question is better if you just put it on our forum. I would go into more details there. Right now, since the audience is mostly new to the ecosystem, I may want to keep it very general. So it will be great if you come over to the forum and ask the question there. Okay. Again, a question is how Storm is different from Spark. Quick answer is Storm is not very general engine, while Storm is extremely fast as compared to Spark. Storm is designed for stream processing specifically, while Spark is designed for batch processing initially, but has been used for the stream processing as well. Okay. What does scalable computing means? Scalable computing means that when if we are using 5 computers today to do the computing, if tomorrow we have 20 computers, we should be able to do we need not change our code. Okay, that's what is scalable computing. Is this similar to Splunk? Does this course help if we are using Splunk? What is the final outcome of the course? Final outcome of the course is that you should be able to process all kinds of data using Hadoop and Spark. You should be able to architect big data solutions, and you should be able to architect the solutions understanding the actual requirements of handling humongous data. Okay, so if you are coming from Splunk, this is definitely a complementary course. Splunk is mainly for the visualization and the data pipelines. So this one will be a complementary one. Question from Noor, HDFS is analogous to database file. Then what is database engine? HDFS is not analogous to database, but HDFS is more analogous to the file system. Okay. What is difference between Zookeeper and Yarn and when they come into play? I think this we have answered. Zookeeper is for coordination between various services. Zookeeper is an independent service, while Yarn is a part of Hadoop, and Yarn interacts with Zookeeper to keep track of other Yarn services. Okay, so Yarn uses Zookeeper in order to coordinate between its own services. A question from Nayan. HBase is for semi-structured data. That's right. Object storage also creates the same distributed block of data. How are they different? Okay, so I'll have to take a look at the object storage to be able to answer the question. Would you come over to the forum to ask this question? I would love to answer it there. Okay, a question is, can you tell me which situation we will go for Spark and MapReduce? So for most of the cases, we'll be using Spark for computing, and will not be using the Hadoop MapReduce for computing. All right, anything that can be done with MapReduce can be done with Spark. Okay. A question is, if we go for Uzi, how will it know what patterns we want the data to be transformed? Good question. So it basically does not do that. Instead, it gives us okay, let me just open my workflow. Right. So here what you see is, let's say we want to do some kind of processing, correct? So let's say we want to use pig for processing. So when we drag and drop pig, it is asking for the pig script location. So we will have to define our script. Uzi will only run it. Okay. So a question from Robin is, I'm just curious what tools are being considered by Hadoop ecosystem to replace big ETL. So the tools that we generally use as ETL as of today, I'll be very honest. If I have a choice right now to do the ETL on some data, I'll use Spark instead of any of the Hadoop components. Okay. So what is the, and if, with respect to Hadoop, right? If instead of pigletten, you can actually use Hive, or there is something called Hadoop MapReduce streaming. So that is also an equivalent of quick processing of the data. Okay, so I hope that answers your question. Question from Hitendra is, what's the difference between Zookeeper and Oozie? Oozie is for entire workflow, while Zookeeper is a tiny storage in which you can write, and it's basically for coordination. Just like various salesmen in a room keep track of their performance by using a whiteboard in front of them. Similarly, many services keep track of each other using the Zookeeper as the whiteboard. Zookeeper is a tiny storage in the network on which people can write and so on. So it provides the coordination by the way of a central store, tiny central storage. Okay, we will cover Zookeeper in more detail in the second session. A question from Karun. Can you please explain lifecycle of Hadoop job from invocation to getting results from Hadoop node etc? We will go into more detail in the Hadoop MapReduce session because that's pretty much, it will take at least 1 hour of my time. Okay. A question from Grishma. The in HDFS data will be stored in what pattern? Anything like so in HDFS data will be stored in the file format, and it won't be storing in RDBMS or object based. Okay, just to give you a clear thought. So if you go in here into my lab and go into say Hue, and let me just close it, go to file browser. So this is how you see here there are folders, files. This is HDFS. This is my home directory in HDFS. So you can see that this is the top level directory in HDFS, and this is my home directory inside user. Okay, while this directory that you see inside Jupyter is the directory on the local computer, localcomputer.cloud.cloudxlab.com, not in the HDFS. So you see, it is very similar to the normal file system of the computer. It has folders, it has files, and so on. So I think that will answer your question. Okay. Can we, yeah. The lab which you provide for training, what's the limit of data size? You can store up to 4 GB of data in the HDFS. Okay, so a question from Noor is, can we store relational data here? Yes, you can definitely store relational data. Not really. Okay, let me take a step back. When we talk about relational data is when we have a table and having primary key, foreign key relationships. That can be done by using any of the systems like Hive or HBase or anything like that. None of them provide the relationships between the databases. Okay. Question is, what are the popular paradigms of distributed computing other than Hadoop and Spark? Popular paradigms of distributed computing other than Hadoop and Spark. So the other comparable distributed computing paradigm would be using say Storm, where you have bolts, and there is something called bolts, and there's one more term there. So that's another paradigm of distributed computing. All right. A question from Binda: should we be familiar with all data sources? I'm not familiar with Tachyon and Cassandra. No need to be familiar with that, because it just at the initial point we just have to specify the data source, and rest of the data formats will remain as such. Okay. Can complex ETL activities be handled by Spark? If yes, how? So the Spark provides you all kinds of data sources. It can read from CSV, tab separated, and so on. In case you want to design your own complex data loader, you can do that using Spark. Even the transformation, so extracting the data can be done easily. Similarly, transformation can be done easily using Spark. It provides you all kinds of pipelines, all kinds of map, reduce, and reduce by key, group by this and that. So it's a huge in detail. That's what we will cover in like 3 classes, 3 as in around 10 hours of session. We will cover how to do the ETL or programming with Spark in order to achieve any complex results. Okay, so question is, where are we doing the data cleaning process? That's what is ETL is generally done using Spark. So a question from Deepak, do you think advancing in serverless computing can make Spark less relevant in future? So Spark is actually serverless computing. All right. So I won't go into that much in detail. That's okay. So you could come over to the forum and ask this question because it deserves a bit more treatment. Okay. A question from Rajan, is Spark used to push data into HDFS? So we can use, yeah. All right. So we have already discussed a couple of use cases of Spark. Could you come over to the forum? I would love to answer it in detail. This question requires a big treatment. All right. So a question from Robin is, can Hadoop integrate with log analysis platforms such as Splunk? It should be able to. We'll just have to take a look at it. Again, come over to the forum. We would love to answer. Okay. And yes, in what format data is stored in HDFS that makes it demanding? So HDFS basically provide you the data in the form of folder structures, and just like the way I have shown you in just now here, you can see it just files and formats. Under the hood, it is placing these files in the network, and that is basically slicing these files into small blocks. Okay, in which situation we will choose Spark and MapReduce or only Spark? In almost every case, you can actually go with Spark. Okay, what is the minimal desktop and to install Hadoop to set up a lab in home, any Linux distribution? So I would say that in case you are trying to set up a desktop PC with a single machine, so instead of installing all the services, why you should generally use something called virtual machine. So Hadoop, Hortonworks and Cloudera, they both provide their own virtual machine, but that would require minimum of 8 GB of RAM. Okay, so basically, instead of worrying about installing Linux bottom up, you can just download a virtual machine and launch it on your Windows computer or Mac computer or anything. Okay. But I would I would suggest that that's basically a messy process of installation, and generally hardware comes in the way. Instead, you could just go with CloudxLab kind of environment. Okay. Do you mean HBase would sit on HDFS to store data? So yes. So HDFS is storing data in the form of files, while HBase is storing data in the form of tables having columns and rows. Okay. Can you please explain Hadoop Spark job lifecycle? We'll talk about it later. And if you come over to the forum, I could answer there. Okay, it is good to switch to big data from BI. Yes, that's the next step in that dimension. Okay, and in which situation, this we have already answered. Okay. All right. So Hadoop ecosystem, Hadoop Spark job lifecycle is going to be a bigger one, so we can talk about it at later point of time. Okay, is there a tool to collect data? Flume is the one that does the job of collecting data. Okay, a question is, to master big data and data science, do I need to learn both Scala and Python, or only Python is enough? I would say that go through both. Okay, and in case of Spark, you can actually use Python. If you are just interested in learning Python, actually Python should suffice doing both. Okay, but it won't hurt learning a new language because both Scala and Python are very similar to each other, and it won't be too hard for you. Trust me on this. Okay. All right. Now, okay, this one we have answered. Will you introduce basic syntax about environment configuration during the courses? Yes, we'll go over a bit of configuration, but we'll just help you with the references if you want to set up your own environment. Okay. All right. Wherever required, I'll describe to you what does it mean by environment configuration. Okay. So I'm enrolled for the course. We have received the instructions for PC setup needed for the next Saturday class. So you don't need to set up anything. Okay. You don't need to set up anything at all. You can just log into my lab and you will see these credentials and start using it. Okay. If you want, you can just send me a message. We will reply you with all detail if you want to set up your own desktop, but that's not really required. You don't need it. You can just use the lab that is available right there. Okay. A question is, when installing Hadoop on-premise or in our laptop, what software licenses do we need to purchase? During our course, will you provide the necessary software to install? So one is you don't need to install anything at all if in this course, because we are not we are using that on the cluster. Second is Hadoop. All of these tools are open source, and there is no licenses as such. Okay. The only license that might require is for visualization tools such as Tableau, that you can generally just take a trial version and use it. Except for Tableau, rest of the ecosystem is open source uh, and and so on. All right. So Satya, those questions, there are some questions I've not been able to answer and delegating it to the forum. Come over to the forum. Trust me, it's going, here is the forum. If you click on discussions, this is that forum. I'll just show you. So come over to the discuss. I would love to answer your questions. Question is, you already mentioned that you provide the presentation you, but also provide the session videos, including audio. Just if I happen to miss. Yeah, we actually record. So those who are enrolling with our courses, what you get as part of the course, number one, the live classes. Second, the studio recorded version of the classes. Third, the recording of the classes. Fourth, you'll get the lab. You'll get the entire access to the lab for 3 months from the starting day. Okay, so that's how it. Those are the things, along with all the presentation exercises and automated hands-on assessments. All of that is provided as part of the course. Okay, how feature extraction is done in Spark environment. Using MLlib, you can do the feature extraction. Okay, you can also use the ETL environment available to do the feature extraction on your data. Okay, what is your schedule for the next Hadoop session? The next session is going to be on the next Saturday. Okay, next Saturday. So second session is going to be on next Saturday. A question from Binta: should we be familiar with all data sources? No, you don't need to be. Tell me about various Hadoop daemons and their roles in Hadoop cluster. So you can take a look at the Ambari and you will get a picture of which are the services running and in the backend, and you will get the idea. So we'll go into these details at a later point of time. Okay, or you come over to the forum and I'll explain there, because this deserves a better answer than this. Okay, if we have all raw data in data lake, how we do small data marts based and type of the data where we store this. If we have raw data in data lake, okay, all right. So let me understand. If we have all raw data in data lake, how we do small data marts based on type of the data and where we store these marts. Okay, so I think again this one I would love to answer in more detail. Come over the forum, because I need to describe in more details what does it mean by data mart and all. Okay. So does Spark is more efficient than MongoDB MapReduce? So MongoDB is also provides a storage while Spark does not. MapReduce, yes, it's definitely more efficient. Okay, and a question from Samir: is blockchain processing required Hadoop Spark frameworks? So question is, will can we utilize Hadoop and Spark framework for blockchain processing? If the data is bigger, which is the case with blockchain, you can utilize Hadoop and Spark. But Blockchain is very GPU intensive. Therefore, distributing data takes more time as compared to processing data on the same computer. Therefore, doing a transaction using the blockchain, it's better to use GPU than Hadoop and Spark framework, because there it's not very disk IO intensive. Okay, it's more CPU intensive, or it's not RAM intensive. Therefore, blockchain processing is generally um, uh, better to be done on GPU. Okay, there. So a question from Binta: what's the difference between database and data source? Database provides many features. Okay, so data source is any source of data. It could be a database, it could be a file system, it could be any other place from where we can read data. While database is something that provides you a storage where you can store data, create data, update data, delete data, or the database as a term is also provides you all kinds of transactional guarantees, which data source does not. Data source could be read-only. Okay. Can you explain again HBase? HBase is basically a relational kind. It's not relational. It's kind of semi-structured tabular storage. So HBase is for storing data in a tabular format. When we need to say delete a particular value in a particular column or in a particular row, then HBase comes very handy, because deleting a particular record in file system is very hard. In case of file system, if you want to delete a particular line, we might end up rewriting the whole file. Therefore, when you have to do the record-based processing, update a particular record, delete a particular cell, or update a particular cell, in that case, HBase comes very handy. HBase can store billions of rows and billions of columns, okay, on top of and since it uses HDFS, the entire thing is massively distributable. Okay. A question is, what are the career options on completion of this course? Does Cloudera or Hortonworks certification help? Okay. So a question is, what are the career options after completion of this course? Most of our students have moved to the big data engineer career after attending the course, which is generally better for more rewarding, and and those basically there are many available here, many options in this. Basically, one is big data engineer, big data architect, data engineer, or data architect, along with the along with the uh, uh, along with that, if you have gone through the basics of analytics, you might choose your career in the data science world. So now the next question is, does Cloudera and Hortonworks certification help? It does help, but I would say that if a company is serious about hiring big data engineers, they generally have their own tests other than Cloudera and Hortonworks certificate. Okay, so basically it is going to take it's basically so the companies who are setting up newly their big data practices, they might rely on the third party certification, but the companies which are more focused towards the enhancing their existing practice of big data, they would have their own interview process, and hence in those cases the certification may not help. All right. Okay, so again, with respect to the summary of career path, I would love to answer it. Come over to the forum. I would basically peacefully answer this question. Okay. A question from Noor. So we are doing everything in Spark, so there will be no more value of MapReduce. So even though we won't be using MapReduce too much to solve most of the processes, but we would learn the Hadoop's MapReduce, because as a concept, it is a very valuable concept in distributed computing. Okay, therefore it is very much required to learn that part. Okay, can JDK be installed in Windows with Eclipse? Yes, you can just download JDK and install. Okay, all right. A question from Rajan. You already mentioned that you provide the presentation. Okay. Yes, I think I have answered this question. A question from Robert. Our company uses firewall and they restrict. Would they? I would like to ask if where to find the list of port services used by each component of Hadoop ecosystem. So, all right, that's if you are using the lab, then all you need is just check these URLs if they are opening on your machine. All right. If you are using the CloudxLab, you can just generally go to here and click on, say, My Lab, and just check if these are opening on your machine. Okay. So that would generally give an answer. And that should give you a overview of what's, as in whether a particular port is open or not. Okay. In case you're planning to set up your own cluster, in that case, we'll have to work in detail. So again, if you ask this question on the form, I can give you a detail of all the ports and we'll give you that. Okay. A question from Subbu. I am from BI background and do not have any language skills, and I am going to good at Shell and SQL. How much language skills required for Hadoop? So in the first part, you won't require too much of skill. And interestingly, the part that we cover in Hadoop, we use actually the shell. Hadoop MapReduce, we actually use the shell here. So we basically cover a simple example on MapReduce. There, we will be doing the MapReduce with shell. Okay. And the skills that would be required in the second part, which is Spark, there we'll be learning Scala, okay, as part of this course. Is HDFS only read-only, as it's difficult to delete data? No, it's not read-only. You can delete and update data. Like for example, I could just create a new folder here, okay, and also upload some data. And let me just show you that I could just delete this particular file. Okay. All right. So question is how do you charge one-on-one mentoring? So all right. So if you drop an email to us on Reaches, I could explain to you the one-on-one mentoring part. All right. Great. So yeah. S- So great set of questions. I totally loved your questions. I look forward to see you in the next session. Okay, so there are around 2 or 3 more seats left in the course. Please come over to the session, and yeah, I would love to see you. Thank you, everyone. Have a great day. Bye bye. You will get the video and the presentation in the email, as well as those who have enrolled for the course. In their My Courses, there will be, in the My Courses of yours, you will see 2 courses. One will be this kind of a course, Big Data with Hadoop and Spark. This one contains exercises and a studio recorded version of these discussions. And, and you will also see this kind of a course, which contains the recording. Okay. This one will be containing the recordings, I think. Okay, so all right, so have a good day, and I hope this was useful to you, and feel free to reach out to us. And there's a lot of content that you could attend to, and there are many videos and exercises that you could attend to. And if you're interested in the course, you can just enroll from here. Okay. So if you have further questions, come over to the discussion. If you have questions related to enrolling and something that is a little more confidential, write to us at reach us at CloudxLab. Okay, write to us at reach@CloudxLab. Thank you, everyone. It was great to have all of you in the session. Wonderful set of questions. Keep asking questions because that's the only way to learn. All right. See you all next week. Bye bye. Have a good day. Okay. I look forward to see you either in the class or at least on the forum. Here you can enroll in the class using enroll now, or you can come over to discussions. Bye bye. Have a good day.